Hello, and welcome to The Sleepy Scientist. This is the place where we gently wander through the universe, one quiet question at a time, designed to help you relax, wind down, and maybe even learn a thing or two on your way to sleep. Tonight we're turning our gaze to the moon, our constant companion in the night sky. It's easy to take it for granted, hanging there so silently, but without it, Earth and life itself might have been a very different story. From tides to timekeeping, from ancient myths to modern science, the moon has been shaping our world in quiet, powerful ways. Now I'll do my best not to make this too fascinating. I'd hate for you to stay awake from sheer lunar excitement, but if you do end up wide-eyed at 3 a.m, at least you'll be able to explain axial tilt and tidal resonance to your houseplants. Before we begin, if you enjoy these calming cosmic journeys, please consider giving the video a like and subscribing to the channel. It helps more sleepy souls find their way here. And let me know in the comments where you're listening from and what time it is where you are. Whether you're drifting off at midnight or listening on a quiet afternoon, I'm glad you're here. So get comfortable, breathe deeply, and let's wander together into the gentle light of the moon. And just so you know, nothing in this video is medical advice. I'm here to relax your neurons, not recalibrate them. Imagine looking up at the night sky and seeing nothing. Well, not nothing. The stars would still be there, blinking gently in the dark. Planets would still trace their paths. But the moon, that gentle glowing disk that has accompanied life on Earth for billions of years, gone. No full moons, no crescents, no lunar eclipses, and no silver light casting shadows across a sleeping world. Just an emptiness where something should be, a missing rhythm, a silence. It's easy to forget just how much the moon does. It sits up there so quietly, not demanding attention, not pulsing or flashing or burning like the sun. And yet, behind that quiet exterior lies a force that has helped shape everything from our planet's motion to the rhythms of life itself. Without the moon, Earth would still exist, of course, but it would be a wilder, more chaotic, and far less hospitable place. Let's start with one of the moon's most crucial roles, helping to steady our planet's tilt. Earth spins on its axis, and that axis is tilted at about 23.5 degrees. That tilt gives us our seasons. When the northern hemisphere leans toward the sun, it's summer up there. When it leans away, it's winter. The same goes for the southern hemisphere, just reversed. This axial tilt has been remarkably stable for millions of years, and we can thank the moon for that. Without a moon, Earth's axial tilt would wobble dramatically over time. Picture a spinning top that's starting to slow down and wobble. It's still spinning, but its angle keeps shifting unpredictably. That would be Earth. Instead of gentle, reliable seasons, we might experience wild swings. Some periods could see no seasons at all, while others could bring unbearable extremes. Imagine an Earth where the poles tilt so far that they point directly at the sun, creating tropical conditions at what we now call the Arctic, and later swing back the other way into icy darkness. Not exactly ideal for growing tomatoes or planning a summer holiday. This wobble, known as obliquity variation, can still happen on Earth even with the moon. But thanks to the moon's gravitational influence, those variations are relatively minor. Just a few degrees back and forth over tens of thousands of years. It's the moon's mass and position that act like a cosmic stabilizer, damping down wild oscillations and keeping Earth's climate from turning into a planetary mood swing. Then there are the tides, the daily dance of the ocean, rising and falling with predictable rhythm, is largely driven by the moon's gravity tugging at Earth's waters. Without the moon, Earth would still have tides, but they would be much weaker, driven mostly by the sun, and only about a third as strong as what we see today. At first glance, that might not seem like a huge problem, but those stronger lunar tides have played an important role in the history of life. Picture early Earth, billions of years ago. The oceans teemed with primitive organisms, many of them clinging to the edge between land and sea. Tidal pools, Those shallow, sun-warmed puddles left behind as the tide retreated were nature's chemistry labs. In those tiny, shifting worlds, compounds could concentrate, dry out, react, and then get replenished by the next wave. Over countless cycles, this push and pull may have helped the first complex molecules assemble into something more lifelike. Life might have begun, or at least gained momentum in the gentle back-and-forth rhythm of the tides. With weak tides, those dynamic environments might never have formed, or at least not in the same way. Life could still have emerged eventually, but perhaps more slowly, or along a different path. And even after life appeared, tides continued to influence it. Marine animals evolved to feed, migrate, and reproduce, in sync with tidal rhythms. Coral spawning events, for example, are often timed with lunar cycles. Take away the moon, and a great deal of ecological choreography might fall out of sync. Beyond biology and climate, there's the simple, psychological role of the moon. Since ancient times, humans have looked up at that glowing sphere and found comfort, mystery, and inspiration. It has lit the way for travellers, marked the passage of time, and filled poetry with metaphors both elegant and cheesy. Remove the moon, and entire mythologies unravel. No lunar calendars, no moon festivals, no werewolves. And speaking of werewolves, the absence of the moon would take a bite out of popular culture too. No eerie full moons to howl at, no midnight transformations, no moody black and white shots of a lonely highway bathed in silver light. Love songs would be a little less romantic. Literature would lose one of its most enduring symbols. Even modern storytelling, from science fiction epics to bedtime tales, would feel slightly emptier without that familiar glow hanging overhead. But even more practically, humans would have lost one of their first and most reliable timekeepers. Long before wristwatches or phone screens, early humans tracked time by observing the moon's phases. A complete lunar cycle from new moon to full and back again takes about 29.5 days, conveniently close to a calendar month. This regularity helped ancient people plan agriculture, rituals, and travel. Without it, timekeeping would have been much trickier in early civilizations. The moon served as a cosmic reminder that, yes, things do run in cycles, that there is order, even in the dark. The absence of a moon also means the nights would be much darker. It's hard to overstate just how much moonlight matters when you don't have streetlights, flashlights, or glowing screens. Before artificial lighting, the full moon illuminated paths, fields, forests, and faces. It gave hunters and travellers an advantage, shaped behaviour in nocturnal animals, and even influenced crime rates and sleep patterns in human communities. Without the moon, the night would feel much more complete in its darkness, less alive somehow, a little colder, a little more alone. Now, let's consider Earth's rotation. The moon has been gradually slowing Earth's spin through a process called tidal friction. When Earth was young, a day might have lasted only 5 or 6 hours. The moon's gravitational tug has steadily stretched that out to the 24-hour day we experience now. Without the moon, that slowing effect would have been greatly reduced. Our planet might still be spinning much faster, with much shorter days. Imagine living on a planet where the sun rises and sets every 6 hours. Our internal clocks, our circadian rhythms, might have developed in a completely different way. Everything from metabolism to sleep to the very way we experience time could be unfamiliar. Even more curiously, some planetary scientists believe that without the moon's moderating influence, Earth might have become a less stable environment overall, not just in climate, but in plate tectonics, magnetic field generation, and even core cooling. While those ideas are still being debated, the general consensus is that the moon is a major reason Earth has remained geologically and atmospherically active, and therefore habitable, for billions of years. It's easy to see the moon as just a nightlight in the sky, something pretty to look at when the clouds part. But it's been much more than that. It's been a silent architect, a planetary partner, and a backstage manager making sure the show runs smoothly. If Earth is the main actor in the story of life, then the Moon has been the quiet director. Unseen, unthanked, but vital. Without it, we might still be here, but the journey would have been much harder, the path less steady, and the sky far more empty. No moonlight walks, no howling wolves, and no cheesy romantic metaphors. Just a dark stage and a spinning planet trying to find its balance in the cosmos. Let's take a moment to rewind time, not just a few centuries or millennia, but all the way back to the chaotic, swirling mess that was the early solar system. Imagine space not as the calm, dark void we often picture, but as a busy construction zone filled with dust, fire and flying debris. The sun was young and bright, and planets were still in the process of becoming themselves. Earth, as we know it, was just one of many planetary embryos, growing, colliding, reshaping and trying to find its form. In the middle of all this cosmic chaos, something happened. Something big. A dramatic planetary-scale event that changed everything. One of the most widely accepted theories about how the Moon came to be is called the giant impact hypothesis, and as the name suggests, it involves one very large and very violent collision. Roughly 4.5 billion years ago, when Earth was still molten and incomplete, a Mars-sized object named Theia, after the Titaness of Greek mythology who gave birth to the moon goddess Selene, drifted into Earth's neighbourhood. This was no gentle tap. Theia collided with Earth in a glancing, high-energy impact. The result was cataclysmic. Vast amounts of material from both Theia and Earth were ejected into space, creating a glowing, red-hot ring of debris encircling our young planet. This wasn't your average asteroid impact. This was two planetary bodies colliding at tens of thousands of kilometers per hour, generating enough heat to melt rock and vaporize mountains. The energy released was unimaginable, on a scale far beyond any volcanic eruption or explosion Earth has ever seen since. Think of it as a planetary-scale reset button. Earth was torn open, reshaped, and surrounded by a temporary halo of its own innards. Over time, likely within a few years, though some models suggest it could have taken longer, that ring of molten debris began to clump together. Gravity, ever the patient sculptor, started drawing those bits into a single object. This glowing mass cooled, solidified, and became the Moon. Our Moon, formed from the ashes of planetary violence. Now this idea might sound like something out of science fiction, but it's backed by a lot of compelling evidence. For starters, the composition of moon rocks, brought back by the Apollo missions, is strikingly similar to the rocks found in Earth's outer layers. They're not identical, but close enough to suggest a shared history. What's more, the Moon is strangely lacking in volatile elements, things that evaporate easily, which fits with the idea that it formed in the superheated aftermath of a massive impact. There are other clues too. The Moon's orbit, its density, and its lack of a large iron core all support the notion that it was born from Earth, rather than being captured from elsewhere. If the Moon had come from another part of the solar system, its chemical signature would likely be quite different. Instead, it looks like it came from Earth's mantle, mixed with the remains of Theia, fused together in space. This makes the Moon quite special in the cosmic scheme of things. Most moons in the solar system are either captured asteroids or pieces of debris from other processes. Mars, for example, has two tiny moons, Phobos and Deimos, that are probably captured objects, irregularly shaped and small. Jupiter and Saturn have dozens of moons, but they're all much smaller relative to their planets, and many are icy, distant, and pulled in by gravity long after their host planets formed. Earth's moon, by contrast, is enormous compared to its planet. It's about 1/4 the diameter of Earth, and roughly 1/80th of Earth's mass. That's unusually large for a moon, and especially odd given how close it is. In fact, among all the moons in the solar system, ours is the biggest in proportion to its planet, with the possible exception of Pluto and Charon, which are more like a double dwarf planet system. This size matters. A large moon exerts a stronger gravitational influence. It has enough heft to interact significantly with its planet, shaping tides, stabilizing tilt, and slowing rotation over time. In Earth's case, the Moon's presence has helped create a remarkably stable environment that has allowed life to develop and flourish. But the story gets even stranger. If the Moon formed from a mix of Earth and Theia, what happened to Theia's remains? Did it vanish entirely into the Moon? Was it absorbed into Earth? Some scientists think parts of Theia may still be buried deep within Earth's mantle, as mysterious regions of denser rock detected by seismic waves. Others suggest that most of Theia's mass simply vaporized or became part of the Moon's bulk. What's clear is that Earth and the Moon are more than just neighbours. They're cosmic siblings, born of the same violent event, forged from the same raw materials and forever bound by gravity. They spin together in a delicate dance, each affecting the other's motion in subtle ways. It's a relationship that goes far beyond mere companionship. The Moon may be orbiting Earth, but the two of them are part of the same original story, and that story, while widely accepted, is still evolving. Scientists continue to refine models of the giant impact, using computer simulations and data from lunar missions. Some newer versions of the theory suggest that Theia's impact was even more direct than we once thought, or that Earth and Theia were already partially merged before the collision. There are even hypotheses that suggest multiple smaller impacts might have contributed to the Moon's birth. One particularly interesting twist is the synestia model. In this version, the collision between Earth and Theia created not just a debris ring, but a vast donut-shaped cloud of vaporized rock, a kind of planetary torus, that eventually condensed into both the Earth and the Moon. This could explain some of the more puzzling similarities in their composition. Whatever the exact sequence of events, one thing remains clear. The Moon didn't just show up one day like a housewarming gift. It was born in fire, forged from destruction, and sculpted by gravity over time. It is quite literally a piece of Earth that took to the sky. That connection gives the Moon a unique place in our understanding of the cosmos. It's not just a rock orbiting our planet, it's a monument to our violent origins, a relic of the time when Earth itself was still finding its shape. Every time we look up at the Moon, we're seeing part of ourselves, spun out into space, suspended in silence. In a universe full of distant stars and frozen moons, this one is unusually close and unusually connected. And while it may appear still and silent now, its origin story is anything but. The Moon is proof that even in the aftermath of chaos, something beautiful and stabilizing can emerge. A cosmic twin, shaped in collision, lighting our nights and anchoring our days. Earth is a planet with a bit of a lean, not enough to fall over, but just enough to keep things interesting. Our planet doesn't spin perfectly upright like a top. It's tilted at a comfortable angle of about 23.5 degrees. That tilt is the reason we have seasons. As Earth makes its yearly journey around the Sun, different parts of the planet lean toward or away from the sunlight. This gentle, consistent shift gives us springtime blossoms, autumn leaves, summer sunshine, and winter snow. It's a simple tilt, but it has profound consequences for life on Earth. Now, here's the twist. Literally. That tilt is not just a one-time feature stamped into Earth like a factory setting. It's a delicate balance, and it's being quietly maintained by a cosmic partner, the Moon. Without the Moon, Earth's tilt would wobble like a toddler learning to walk, staggering one way, then lurching back another. Over time, this kind of instability could have made Earth a much less friendly place for life. To understand why the tilt matters, imagine what would happen if it started to shift wildly. Earth's axis is like the axle of a spinning wheel, angled just enough to keep the ride smooth. But gravitational forces from the Sun, other planets, especially Jupiter, and even the uneven distribution of Earth's own mass are constantly tugging at that axle. It wants to drift, to wobble, to change. That wobble is called axial precession, and it happens even now slowly and predictably. But without a stabilizer, something to hold the axis in check, those small nudges could grow into major swings. The moon acts as that stabilizer. Its gravitational pull provides a kind of counterweight to the forces trying to jostle Earth off balance. Like a gyroscope helping a spacecraft maintain its orientation, the moon exerts a steadying influence. With its help, Earth's axial tilt only varies by a few degrees, between about 22 and 24.5 degrees, over tens of thousands of years. That's a gentle sway, and it allows the climate to remain relatively stable over long periods. But take the moon away, and things get unpredictable. Without the lunar stabilizer, Earth's tilt could start to swing much more dramatically. Some models suggest it could vary by as much as 10, 20, or even 60 degrees over long stretches of time. A 60-degree tilt would be catastrophic. Imagine the polar regions pointing directly at the sun for months at a time, while the equator shivers in long darkness. That would turn the idea of seasons on its head. Instead of a predictable cycle of spring, summer, autumn, and winter, we'd have erratic and extreme climate shifts. A region that is temperate today might become a scorched desert in one era and a frozen wasteland in another. Crops wouldn't know when to grow. Animals wouldn't know when to migrate, mate, or hibernate. Ecosystems would constantly be stressed by the instability, and many might not survive the chaos. Even the oceans would suffer. Ocean currents, those global rivers of moving water that help distribute heat around the planet, are influenced by Earth's tilt. With a wild tilt, those currents could become disrupted or even reverse direction. That would dramatically affect weather patterns, storm systems, and rainfall distribution. The result would be global climate whiplash, where stability becomes a distant memory. Now, if this all sounds a bit abstract, let's look at a real-world example. Mars. Our red neighbour also has a tilt. In fact, it's tilted at about 25 degrees, almost identical to Earth's. Mars also experiences seasons, and you can even see polar ice caps growing and shrinking with the Martian year. But unlike Earth, Mars doesn't have a big moon to help keep that tilt in check. Mars has two tiny moons, Phobos and Deimos. They're irregular potato-shaped rocks that were likely captured from the asteroid belt. They don't exert much gravitational influence, and certainly not enough to stabilize Mars's tilt. As a result, Mars's axial tilt has likely varied dramatically over time. Estimates suggest it may have ranged from as little as 15 degrees to more than 35 degrees, and possibly even higher over longer timescales. This wobble has huge implications for Mars's climate. It's one reason why scientists believe Mars may once have had liquid water on its surface, in lakes, rivers, and even shallow seas. But as the tilt changed, the climate shifted, and that water may have frozen or evaporated into the thin atmosphere. Over time, these changes likely made Mars less hospitable to life, at least on the surface. Back on Earth, the moon has protected us from the same fate. Its steady hand has helped maintain a climate where life not only emerged but flourished. Plants could evolve in sync with reliable seasons. Animals could migrate, mate, and feed with confidence in the rhythms of the year. Human beings could settle in one place, grow crops, and build civilizations, because they knew, more or less, what the weather would do. This predictability shaped everything from agriculture to architecture. Ancient farmers could rely on seasonal rains. Builders oriented temples and homes according to the sun's position at solstices. Cultural festivals celebrated the changing seasons, all of which were made possible by a stable tilt, and by extension, the moon. Even now, in a world of climate-controlled buildings and global food supply chains, we are still deeply tied to the rhythm of the seasons. Our bodies respond to changes in light and temperature. Our moods shift with the coming of spring or the lengthening nights of autumn. Many aspects of human biology, from hormone production to sleep cycles, are subtly tuned to Earth's seasonal clock. Without the moon, that clock might have been smashed to pieces. Of course, Earth's climate has still changed over time. Ice ages have come and gone, deserts have shifted, rainforests have grown and shrunk, but through it all, the basic framework has remained intact. The axis hasn't flipped, the seasons haven't spun out of control, and that consistency has made Earth an unusually stable cradle for life. It's one of those quiet truths that often goes unnoticed. We credit the sun for warmth, water for life, and Earth for its protective atmosphere. But the moon, calm, distant, and slow to change, has been there all along, keeping the planet from wobbling off course. Its role isn't dramatic, but it's essential. You could say the moon is Earth's cosmic chaperone, making sure our planet behaves itself. Or perhaps it's more like a dance partner, leading not with force, but with a quiet, guiding presence. Either way, it's part of a delicate cosmic balance that allows life to thrive. And all of this elegant stability, rests on the simple fact that the moon is just the right size, at just the right distance, exerting just the right pull. Not too big, not too small, not too close, not too far. A perfect balance that's easy to miss when you look up at the night sky, but hard to ignore when you think about how life depends on it. In a universe full of extremes, our tilted, spinning, breathing world is a small miracle, and it spins season after season, year after year, in no small part because a silent guardian tugs gently at our orbit from the night sky. The moon, once born from fire and collision, has become the quiet hand that steadies the Earth. If you've ever stood on a beach and watched the tide roll in, or creep back out, you've witnessed one of the most elegant and persistent forces in nature. Tides are the quiet breath of the ocean, rising and falling in a rhythm that has persisted for billions of years. They're predictable, gentle, and strangely hypnotic. But behind this soothing motion is a tug-of-war between two celestial bodies, Earth and its ever-watchful partner, the Moon. The Moon's gravity is responsible for the majority of Earth's tides. While the Sun also plays a part, roughly a third of the tidal effect, it's the Moon, sitting much closer, that takes the lead. The basic principle is surprisingly simple, though the full mechanics can get wonderfully complex. The Moon pulls on Earth's oceans, drawing the water toward it. But it doesn't just pull on the oceans, it also pulls on Earth itself, though to a lesser extent. This creates a sort of bulge on the side of Earth facing the Moon, where the water is slightly lifted toward the Moon. Interestingly, there's also a second bulge on the opposite side of the planet. This one happens because Earth is being pulled slightly more than the water on its far side, which creates a relative bulge in the other direction. As Earth rotates, these bulges stay more or less aligned with the Moon, causing different parts of the planet to pass through the high tide zones twice each day. Hence, most coastal areas experience 2 high tides and 2 low tides in a roughly 24-hour period. It's a beautiful system, a kind of planetary breathing. But this rhythmic rising and falling isn't just a picturesque feature of seaside life. It has played a starring role in the very origin of life on Earth. Imagine the early Earth, some 4 billion years ago. It was a world of volcanoes, storms, and a restless sea. There were no trees, no birds, no continents as we know them, but there were shallow shores and tidal zones, places where the sea crept up and then receded, again and again. These were not always gentle tides either. The Moon was much closer to Earth back then, perhaps only 20,000 kilometers away. Today it's about 384,000 kilometers distant. With the Moon so near, its gravitational pull would have been far stronger, creating enormous tidal forces. Those ancient tides sloshed water far inland and then pulled it back again. In doing so, they created tidal pools, shallow, temporary bodies of water that warmed in the sunlight and trapped whatever the sea had left behind. And it's in these pools, many scientists believe, that life may have taken its first tentative steps. Tidal pools are remarkable places. Even today they are miniature worlds, isolated, ever-changing laboratories of chemistry and biology. When seawater gets trapped in a pool and then evaporates, it leaves behind a higher concentration of minerals, salts, and organic molecules. Heat from the sun speeds up chemical reactions. Lightning and ultraviolet light provide bursts of energy. And the repeated wetting and drying of these pools may have helped complex molecules form and link together, long chains of carbon-based compounds that eventually became the building blocks of life. In these little pockets of water, protected from the full chaos of the open ocean, but still rich in ingredients, life may have begun. Simple organic compounds could have clumped, interacted, and perhaps even replicated. It's not hard to picture the moon overhead, pulling the tide back, stranding a puddle full of potential, and giving chemistry the time it needed to play. You could say, with just a bit of whimsy, that the moon invented the original water park, complete with slides, splashes, and endless cycles. Except instead of inflatable rings and popsicles, it offered salty pools, volcanic warmth, and just the right amount of chaos. Even after life emerged, tides continued to shape evolution. Marine organisms learned to synchronize their behavior with the rise and fall of the sea. Some species feed only at high tide. Others lay eggs in the safety of outgoing waters. Crabs, mollusks, and countless other creatures have life cycles tuned to the lunar schedule. Coral reefs, for instance, often spawn in mass events linked to full moons and spring tides. The entire reef releases clouds of eggs and sperm in a coordinated dance that covers kilometers of ocean, all cued by the moon. There's something almost poetic about that. Life didn't just arise from the tides, it began to follow them, trust them, even depend on them. The moon became not just a sculptor of the sea, but a silent conductor in the symphony of biology. Tides also shaped early human understanding of the world. Long before people understood gravity or orbital mechanics, they observed the moon's connection to the sea. Fishermen timed their launches according to the tides. Coastal communities watched the moon to predict when the water would rise or fall. The link between lunar phases and tidal movement became one of humanity's first natural calendars. And even inland, far from the coast, the rhythm of the tides continues to echo in subtle ways. Migratory birds use coastal tides to feed during long journeys. River estuaries, where fresh water meets salt, are refreshed and balanced by tidal action. And nutrient cycles in the ocean, which help sustain plankton blooms and global food chains, are influenced by the ebb and flow of the tide. Without strong tides, Earth would be a quieter place. There would still be waves, yes, driven by wind and weather, but the deep global movements that stir nutrients, shape coastlines, and set life's tempo would be far less pronounced. And while life might still have emerged, it likely would have followed a slower, more uncertain path. It's worth noting that tidal forces also affect the solid Earth itself. The crust of our planet flexes slightly under the gravitational pull of the moon. These Earth tides are far smaller than ocean tides, measured in centimetres rather than metres, but they exist, and they demonstrate just how interconnected our planet is with its lunar partner. The moon even helps to stir Earth's interior in subtle ways. Some researchers believe tidal flexing contributes to the movement of tectonic plates, or at least influences the release of stress along fault lines. While this is still a topic of active research, the idea that the moon might play a role in earthquakes, volcanoes, or the churning of the mantle adds yet another layer of depth to our relationship with it. There's a quiet grandeur in knowing that something so far away can shape things so intimately. The moon doesn't shout, it doesn't blaze or boom, it simply pulls, and in doing so, it moves oceans, guides species, and may have helped bring life itself into being. All of this, from the splash of water on the shore to the delicate rhythms of coral and crab, stems from that steady gravitational tug. It's a reminder that even the gentlest forces, given enough time, can shape the world. The tides don't crash like thunder, they whisper and retreat. And yet, they've carved coastlines, sustained ecosystems, and given Earth one of its most vital biological clocks. Next time you find yourself at the beach standing with your toes just beyond the foam, you're standing at the edge of one of the oldest dances on the planet. It's a waltz of water and gravity, written across 4 billion years, choreographed by a moon that continues to pull us gently through time. Whether you're watching the tide come in or the stars blink overhead, the moon is there, steady, reliable, and quietly magnificent. A silent partner in life's journey, pulling at the seas, nudging the planet and offering just enough mischief to keep the shoreline wet and the crabs on their toes. Life has always been a bit of a timekeeper. Even before calendars, clocks, and clever apps that remind us to drink water, life on Earth followed natural rhythms. The sun rises and sets, seasons come and go, and the tides flow in and out like a heartbeat. Among these ancient patterns, the moon's rhythms have left a particularly lasting impression, especially in the early days of life when simplicity ruled and survival depended on syncing up with the world outside. Back when life was still working out the basics, like how to hold itself together or how not to dissolve in salt water, tidal cycles were among the most regular environmental cues available. The moon's pull on the ocean, combined with the rotation of Earth, produced reliable tides that rose and fell roughly every 12.5 hours. These fluctuations weren't just background noise, they were defining features of the coastal and shallow marine environments where many early organisms thrived. Picture a stretch of shoreline on a young Earth. The tide rolls in, covering rocks and tidal flats with nutrient-rich water. Tiny organisms float in, some feeding, others drifting passively. As the tide retreats, pools are left behind, calm, sun-warmed, and filled with the concentrated remains of that brief flood. These pools were natural laboratories and life learned to work with their schedule. Simple life forms began to evolve around these rhythms. Some microbes and early multicellular organisms developed mechanisms to time their activities to the movement of the tides. If you were a creature that needed to feed in shallow water but also avoid drying out when the tide went out, timing was everything. Organisms that could anticipate the return of the tide, or know when to cling to a rock before being washed away, had an edge. Evolution, ever the tinkerer, selected for those who could feel the rhythm. As life grew more complex, so too did the ways it responded to the moon's influence. Beyond just reacting to water levels, many organisms began developing endogenous clocks, internal biological rhythms that didn't just respond to the environment, but predicted it. These internal clocks could be set like timers to the ebb and flow of the tides, the cycle of the moon, or the alternation of day and night. For some species, this meant coordinating feeding with the rising tide. For others, it meant laying eggs only when the moon was full or new, when the tides were at their strongest, and waves could carry offspring safely out to sea. This lunar synchrony is especially well documented in marine invertebrates. Coral reefs, for example, perform one of the most spectacular lunar-timed events on Earth. On certain nights of the year, always tied to a full moon, entire reefs release clouds of eggs and sperm into the water simultaneously. The timing is so precise that neighbouring coral colonies coordinate across kilometres of ocean. It's a dazzling, if somewhat slimy, celebration of reproduction. Why such precision? Because in the ocean, timing is survival. Release your eggs too early, and they drift away alone. Too late, and the window has passed. But if everyone spawns at once, the chances of successful fertilization skyrocket, and predators can't possibly eat all the drifting gametes. It's the classic strength in numbers strategy, fine-tuned to the lunar calendar. It's not just corals either. Grunion fish in California famously ride the waves during spring high tides, those extra high tides associated with full and new moons, to flop onto sandy beaches and lay their eggs. These fish arrive under moonlit skies, deposit their offspring in damp sand, and vanish before the water retreats. 2 weeks later, just as the next high tide arrives, the eggs hatch, and the tiny fish are washed into the sea. Crustaceans like fiddler crabs and horseshoe crabs also time their mating and spawning to the moon cycles. Horseshoe crabs, those ancient armoured survivors from the age of trilobites, emerge in massive numbers during spring high tides to mate in the shallows. They've been doing it for hundreds of millions of years, utterly unfazed by changing coastlines or modern beachgoers with cameras. These behaviours aren't simply responses to the tides as they happen. Many of these animals are using internal lunar clocks, even in laboratory conditions where there are no tides or visible moons. They continue to cycle through their behaviours with astonishing accuracy. That suggests the moon's rhythms aren't just external cues, they're wired into biology itself. And the influence doesn't stop at reproduction. Feeding behaviours, migration, and even patterns of movement can follow lunar cycles. Some plankton species migrate vertically in the water column depending on the moon's phase, likely to avoid predators that can see better in brighter moonlight. Certain species of squid and fish adjust their hunting or hiding strategies based on lunar brightness. Even whales have been observed changing their diving behaviour depending on the moon, perhaps because their prey is doing the same. But what about life on land? Surely modern species, especially humans, have moved beyond such lunar dependence, right? Well, not entirely. While most terrestrial animals don't rely on the tides directly, the moon's light and phases still play a role. Nocturnal predators, for instance, often hunt more, or less, during full moons depending on whether their prey becomes easier or harder to spot. Owls and wild cats may reduce their hunting during especially bright nights if their prey is more cautious or harder to surprise. Meanwhile, prey animals like rodents may avoid open areas when the moon is full to reduce the chance of becoming a midnight snack. Amphibians such as frogs and toads often call more during full moons, possibly because sound carries better in still, moonlit conditions, or perhaps because they can see and avoid predators more easily. Insects too can be affected. Some species of moths, for example, navigate using the moon. At least they try to. This system worked beautifully for millions of years until we invented electric lights and confused everything. The result is what you see today. Moths doing dizzy circles around porch lights, trying to steer by a light that isn't 250,000 miles away. Even humans may not be as immune as we like to think. While the evidence is mixed, some studies have suggested that people sleep slightly less or have altered sleep quality during the full moon. The effect is subtle, maybe only 20 minutes or so of lost sleep, but it shows that our bodies might still, in some small way, listen to lunar cues. Whether it's from evolutionary remnants or subconscious awareness of the changing sky, the moon may still tug at us in more ways than we realise. And there's a psychological aspect too. The moon has always been more than just a rock in the sky. It's been a clock, a lantern, a symbol. People have linked it to madness and romance, to fertility and fate. The word lunatic comes from the Latin luna, reflecting the ancient belief that the full moon could unhinge the mind. It probably doesn't, but it's interesting that humans across many cultures saw something powerful in that glowing orb. The moon has shaped more than biology. It has influenced culture, language, and belief. And it all started with that quiet, steady rhythm, tide in, tide out, light and dark, new and full. Early life learned to follow the beat, and that beat still echoes through the living world. Even today, on beaches and in deep sea trenches, in tide pools and coral reefs, creatures great and small are timing their lives to the rhythm of the moon. It's a kind of cosmic choreography, ancient and ongoing, written into DNA and whispered through the waves. The moon doesn't just light the night, it keeps time for the planet. And life, in all its forms, has been dancing to that beat for billions of years. Before the invention of firelight, before torches, candles or lamps, and long before we bathed our cities in the soft hum of electric bulbs, there was only one dependable light source after dark, the moon. While the sun ruled the day, the moon took over the night shift, offering a silvery glow to guide the way through the shadows. For early humans, this glow wasn't just beautiful, it was essential. In a world without artificial light, the difference between a full moon and a moonless night was dramatic. Under a full moon, the world came alive with faint light and clear outlines. Trees cast gentle shadows, animals moved with more confidence, and humans, ever the opportunists, used the opportunity to extend their waking hours. When the moon was high and bright, the nighttime world became accessible, navigable, and just a little less mysterious. Archaeological evidence and anthropological studies suggest that early humans adjusted their behaviour based on lunar phases. On nights when the moon lit up the landscape, it was easier to hunt, gather, and travel. Groups may have planned longer journeys or night hunts around the full moon, knowing they'd be able to see without the risk of stumbling through unseen terrain. Predators could be spotted more easily, paths became visible, and the risk of wandering blindly into danger dropped just a little. The moon may have helped coordinate social activity too. On moonlit nights, people could stay awake longer, interact more, and share stories around the fire without being cloaked in pitch blackness. Imagine a group of early humans sitting in a loose circle, the fire crackling in the centre, and the full moon rising overhead. Shadows flicker on the rocks, faces glow orange in the firelight, and voices rise and fall as tales of ancestors, spirits, and creatures in the dark are shared. In many ways, the moon was the first lamp above the first living rooms. Of course, on moonless nights things changed. The darkness was deeper, more complete. With no stars to walk by and no path lit by the moon, people likely stayed closer to their camps. The crackle of a fire became more than comfort. It became a boundary between light and shadow, between the known and the unknowable. Sounds in the dark carried more weight. The call of an owl, the rustle of grass, the snap of a twig. Each sound could be a harmless animal, or something far more threatening. The moon's absence wasn't just noticed, it was felt. For early hunter-gatherers, the lunar cycle would have provided a kind of natural schedule. The progression from new moon to full and back again offered one of the earliest, most visible patterns in the sky. Unlike the sun, which rose and set each day with a little variation, the moon changed shape. It grew and shrank. It disappeared and reappeared. These changes happened slowly, in a rhythm just long enough to mark time in useful chunks, about 29.5 days, close to what we now call a month. This made the moon a kind of cosmic calendar. You didn't need to carve it into stone or write it on paper. You just had to look up. Is the moon a thin crescent? Then the month is just beginning. Is it round and bright? You're halfway through. Has it vanished entirely? A new cycle is starting. For communities that needed to time migrations, harvests, ceremonies or rituals, this was invaluable. The moon's phases were visible, reliable and universal. You didn't need a sundial or a calendar. You needed a clear sky and a pair of eyes. There's evidence from many cultures, even thousands of years after the earliest humans, that lunar calendars remained dominant for a very long time. From the Babylonians and Mayans to the ancient Chinese and Islamic traditions, months were often measured from one new moon to the next. The word month itself comes from the word moon. It's no coincidence. Even today, lunar calendars continue to shape religious and cultural events around the world, but even before organised calendars, the moon may have helped structure time in another way, by marking the passage of longer cycles like the seasons. Some scholars believe that early humans noticed the moon's position and brightness, not just from night to night, but how it rose in different places throughout the year. They may have tracked the alignment of the moon with certain stars or landmarks to predict seasonal changes, valuable information for deciding when to move, plant or prepare for winter. In cave paintings and archaeological carvings, there are hints that some of our ancestors were keeping track of lunar cycles in symbolic form. Tally marks on bones, notches on stones. Some of these seem to line up with the moon's phases, suggesting that humans were recording time thousands of years before written language. The moon may well have been the first teacher of timekeeping, long before clocks and calendars ever came along. Beyond the practical, though, the moon had an emotional and imaginative impact. It became a character in the stories people told. It waxed and waned, disappeared and returned. And from that mysterious behaviour sprang mythologies. Some saw it as a watchful eye, others saw it as a boat, a face, a goddess, or a spirit. The moon was full of questions, and it patiently invited answers. When you're sitting by a fire, watching the moon rise slowly above the trees, it's easy to start telling stories. The shadows on its surface become animals, warriors, or long-forgotten ancestors. The regular rhythm of its phases becomes the heartbeat of the sky. You imagine that the moon watches you back. Maybe it guides you, maybe it warns you, or maybe it's just always been there, an ancient witness to your tiny part in the vast sweep of time, and through those stories generations connected with one another. Oral traditions passed down knowledge and imagination alike. The moon wasn't just the backdrop for the evening, it was a character in the tale. It listened silently as people named the stars, invented constellations, and spun epics under its light. In cultures around the world, myths grew around the moon. It was a rabbit pounding rice in East Asia, a man carrying wood in Northern Europe, or a jaguar in South America. Sometimes benevolent, sometimes mysterious, sometimes mischievous, but always present. Even as humans developed more complex societies, built cities, and invented artificial light, the moon's influence didn't vanish. It remained embedded in language, folklore, and symbolism. The moon became a metaphor for change, for longing, for reflection. It was linked to femininity, cycles, and the passage of time. Poets found endless inspiration in it. Painters captured its glow in quiet landscapes. Lovers and dreamers alike have gazed at it for comfort and meaning. For our earliest ancestors, though, the moon was simpler and more direct. It lit the path through a dark world. It helped time the hunt. It warned of the coming tide. And it offered company when the stars were cold and the fire burned low. Moonlight was not just a matter of aesthetics, it was a practical tool, a compass, a calendar, and a storyteller all at once. In many ways, the moon helped shape the human relationship with the night. It gave us confidence to explore after sunset. It lent its glow to our gatherings. It carved out a place for night to be something more than a time to hide and sleep. It made the darkness a little less lonely. Today, though we may spend most nights indoors, under artificial lights and glowing screens, that ancient connection still lingers. The full moon still captures our attention. It still has the power to draw us to windows, to beaches, to mountaintops. Somewhere deep in our memory, maybe even in our DNA, we remember a time when moonlight was more than a romantic backdrop. It was a partner, a guide, and a quiet presence watching over us through the long dark hours. Before there were wristwatches, atomic clocks, or little glowing rectangles that told us the exact second in any time zone, there was the moon. Soft, silent, and wonderfully predictable, it kept time in the sky long before humans figured out how to tie sticks together to form sundials. While the sun ruled the hours of the day, the moon quietly became humanity's first long-term calendar, our original cosmic timekeeper. Imagine early humans living in a world without calendars, clocks, or written language. Day and night came and went, but longer periods of time, weeks, months, years, needed some kind of anchor. The moon provided just that. It changed gradually and visibly. A new moon became a crescent, then a half, then a full glowing disk, and then it faded away again. This cycle happened consistently every 29 or so days, offering an easy and natural way to count the passage of time. For hunter-gatherer societies, this rhythm would have been deeply meaningful. If you didn't know what day it was, or even what a day really meant beyond sunrise and sunset, the moon gave you a way to structure your experience of time. One full moon to the next became a convenient unit, a marker to measure intervals. 3 moons ago, we moved to the river valley, or wait until the next full moon to begin the hunt. These were likely some of the earliest concepts of scheduling. Eventually, this cycle gave rise to the concept of the month. In fact, the word month comes directly from moon. A month was originally meant to represent one complete lunar cycle. The match isn't exact. The lunar cycle is roughly 29.5 days, while our calendar months are 30 or 31 days, with February doing its own strange little dance. But the link between the moon and the concept of a month is ancient, and it's baked into the way nearly every culture has thought about time. Lunar calendars were among the earliest tools humans used to organise their lives. These calendars didn't rely on machinery or even writing. They could be built entirely from watching the sky. The moon waxed and waned like clockwork, and early societies quickly realized they could rely on that pattern. Ancient people began marking lunar phases with tally marks on bones, carvings on stones, and symbols etched into cave walls. One of the oldest known examples is the Ashango bone from Central Africa, thought to be over 20,000 years old. It's covered in patterns of notches that some believe represent a lunar calendar, an ancient attempt to track the moon's cycle. This wasn't just idle astronomy. It had real-world applications. Timing was everything when it came to food, knowing when to plant seeds, when to harvest crops, or when to prepare for a seasonal migration. The moon helped early humans coordinate these tasks across a shared time frame. You might not know what April is, but you'd recognize the third moon after the spring rains. Agricultural communities use the moon's cycles to anticipate seasonal changes. A full moon during a certain time of year might signal the best moment to plant millet, or the beginning of the dry season, or when to expect the river to flood. In many cultures, specific full moons were given names to mark these agricultural moments. The harvest moon indicated the time to gather crops, when moonlight stayed longer in the sky to aid with late-night field work. The hunter's moon followed, lighting the way for autumn hunts. Other cultures named moons after environmental cues: the snow moon, the worm moon, the flower moon, each one a poetic and practical reminder of what to expect from nature. And of course, these calendars didn't develop in isolation. Civilizations from Mesopotamia to China to the Americas built elaborate systems of timekeeping around the moon's phases. The Babylonians used a lunar calendar with 12 months, occasionally adding a 13th to keep the calendar aligned with the seasons. The ancient Hebrews also followed a lunar calendar, as do Islamic cultures today, with each month beginning on the sighting of the new crescent moon. The Chinese traditional calendar is lunisolar, which means it tracks both the moon's cycles and the sun's position in the sky. Lunar months guide festivals and ceremonies, while solar terms divide the year into 24 segments based on seasonal changes. It's an elegant system that shows just how deeply intertwined human culture and lunar observation have been. Even the Roman calendar, the ancestor of the modern Gregorian calendar, began with strong lunar roots. The earliest Roman calendar had months that followed the moon's phases, and calends, from which we get the word calendar, originally referred to the first sighting of the new moon. But the moon wasn't only useful for planting and harvesting, it also helped people coordinate social life. Ceremonies, markets, rituals, and religious festivals were often tied to particular lunar phases. A community might gather for a feast every full moon, or observe silence on a new moon. The moon gave everyone the same schedule, regardless of what tribe or valley they lived in. You could simply say, "We'll meet under the next full moon," and everyone knew what you meant, no calendar required. Even in the absence of written language, oral traditions passed down lunar knowledge from one generation to the next. Grandparents could explain which moon brought the rains, which moon signalled mating season for deer, or when the rivers would be at their highest. The moon wasn't just a timekeeper, it was a storyteller, a seasonal guide, and a thread tying communities to the land and sky. Of course, it wasn't a perfect system. The lunar month doesn't divide neatly into the solar year. A year based on 12 lunar months falls about 11 days short of a full solar year, which means purely lunar calendars can drift across the seasons unless periodically corrected. Different cultures developed creative ways to handle this. The Babylonians and Chinese added occasional leap months, while others simply let the lunar calendar roam and accepted that holidays would move gradually through the seasons. That's why, for example, the Islamic holy month of Ramadan shifts each year. It follows a purely lunar cycle. Despite these quirks, lunar calendars endured for millennia, and they still shape the timing of festivals, fasts, and cultural events today. The Lunar New Year, Ramadan, Passover, Easter, and many harvest festivals continue to mark time not with the Earth's trip around the sun, but with the moon's graceful glide through the sky. The moon also offered something most early timekeeping methods couldn't: visibility. You couldn't always see where the sun rose on the horizon if you lived in a valley or thick forest. But the moon was visible from almost anywhere. It hung overhead, unblinking and present, often when people were least busy. At night, after the work was done, it became the perfect companion for evening reflections, planning, and storytelling. You could lie on your back, watch it wax and wane, and begin to understand how time moved in cycles. It's easy to forget in an age of digital alarms and calendar invites that people once told time by moonlight. That, before your smartphone, there was the moon. No charging cable required, no update needed. Just look up, and there it was, keeping its own schedule and quietly helping you keep yours. Even today, many people still feel connected to the moon's rhythm. Gardeners use lunar calendars to decide when to plant and harvest. Fishermen watch the moon for its influence on tides. Farmers in rural areas may still glance at the sky to get a feel for the changing seasons. And some folk simply enjoy tracking the phases out of a quiet habit, watching the moon grow and shrink like a soft, familiar pendulum. In a world that moves faster every day, where time feels crowded and calendars are filled with alerts, the moon offers a slower, softer kind of timekeeping. It reminds us that not everything needs to be measured in seconds. Some things can be counted in shadows, in light, in crescents and circles and quiet drifting days. The moon hasn't changed. It's still there, keeping time for anyone who cares to notice. And though we've built cities, satellites and second hands, there's still something comforting in knowing that our very first calendar still rises with the same grace it always has. It doesn't tick or tock. It doesn't beep. It simply glows. And that might be the most peaceful kind of clock we've ever known. For most of human history, getting from one place to another, especially across open water, wasn't as simple as following road signs or GPS instructions. There were no compasses, no lighthouses, no nautical charts marked with tidy symbols. Yet somehow, people managed to cross rivers, sail along coastlines, and even venture out into the vast open ocean. They did it using clues from the world around them: stars, winds, birds, currents, and yes, the moon. The moon may not seem like an obvious guide for navigation. After all, it drifts across the sky, changing shape and position from night to night. But to those who understood its patterns, the moon became a reliable companion on land and at sea. Its presence offered light to travel by, tides to measure the sea's pulse, and phases that mark the best times for movement and rest. Let's start with something simple and often overlooked: moonlight. Before artificial lighting, travelling at night could be dangerous, disorienting, and sometimes downright impossible. The moon changed that. A full moon lit the world with a soft glow, bright enough to illuminate trails, water, and the silhouettes of trees and hills. On clear nights, travellers could move safely, hunt for food, or make their way along riverbanks and coastlines. For fishermen, the moon meant more working hours. When the tides were right and the moon was full, they could cast nets or check traps late into the night. In fact, some cultures based their fishing schedules on the moon's phases. Fish and other marine creatures often follow lunar rhythms. The increased brightness of a full moon can cause fish to hide in deeper waters or feed at different times. In shallow coastal regions, fish behaviour is closely tied to the tides, which, of course, are governed by the moon. Knowing when the tide would rise or fall wasn't just useful, it was essential. For people living near the sea, the moon and the tides were like a natural clock. The rise and fall of the ocean followed a familiar rhythm, typically 2 high tides and 2 low tides in about 24 hours, but this wasn't random. The timing and strength of tides were linked to the moon's position in the sky. When the moon and the sun aligned during new and full moons, tides were especially strong. These spring tides could flood inland areas or expose tidal flats far from the usual shore. During quarter moons, the gravitational forces worked at angles, creating gentler neap tides. Coastal communities learned to read these patterns with astonishing accuracy. Even without written records or instruments, people knew which nights would bring higher tides, or when to avoid launching boats. In some cases, they built their settlements around tidal cycles, constructing fish traps that only worked during certain phases, or storing food during low tide when the ocean offered up its bounty. But perhaps no people exemplify the marriage of lunar knowledge and navigation better than the Polynesians. These skilled ocean voyagers explored and settled a vast triangle of the Pacific Ocean, stretching from New Zealand in the south to Hawaii in the north and Easter Island in the east. They did this in double-hulled canoes powered by wind and paddle, guided not by compasses or sextants, but by deep knowledge of the natural world. Polynesian navigators used the stars as their main reference, but the moon played a crucial supporting role. It offered light during open sea voyages, allowed sailors to keep track of time during long journeys, and helped mark the direction and phase of tides near unfamiliar islands. These navigators were trained from a young age to observe everything: the position of stars, the shape of waves, the colour of water, the presence of birds, and the rhythm of the moon. One of the most elegant aspects of Polynesian navigation is the concept of etax, a system that used imaginary reference points on the horizon, often involving stars and celestial bodies like the moon, to measure position during travel. Sailors would memorize the rising and setting points of stars in relation to their island departure point, using these as waypoints during their journey. As the moon moved through the sky, it provided additional orientation and helped sailors reset their bearings during cloudy nights or shifting winds. The moon was also used to read the timing of swells. Ocean swells, the long rolling waves that cross great distances, change subtly with lunar tides. Experienced navigators could feel these changes with their bodies, lying flat on the canoe's deck to sense shifts in direction and rhythm. In some traditions, navigators were trained to recognize more than a dozen different wave patterns and knew how to use the moon's position to predict how those waves would behave. And let's not forget the importance of tides when approaching land. A sailor unfamiliar with an island's coastline would need to know when the tide would be high enough to bring a boat safely to shore, or when to avoid getting stranded by receding water. The moon's phase told them what kind of tide to expect. A nearly full moon meant strong tides, greater risk of storm surge, but possibly easier landings if timed right. A waning moon might mean gentler conditions but also more shallow reefs to navigate. In parts of the world where travel depended on rivers and estuaries, the moon continued to influence human movement. Traders and merchants moving goods by boat often timed their journeys to ride the incoming tide upstream, or the outgoing tide back toward the coast. This saved time, energy, and avoided the frustration of rowing against the current. In Europe, river systems like the Thames, the Seine, and the Rhine all have tidal influences. Knowledge of the moon's phases and local tide patterns allowed travellers to plan efficiently, even centuries before mechanical clocks became widespread. In some communities, people use the moon's position in the sky as a rough compass. While not as precise as using the North Star, the moon can be used directionally, especially when it's rising or setting. When the moon is full, it rises near sunset and sets near sunrise, roughly opposite the sun. At other phases, its position at dusk or dawn can help identify east or west. Travellers who understood this could orient themselves on land or sea, particularly when more reliable stellar navigation wasn't available. Even folklore and oral traditions reflect the moon's role in navigation. In some Pacific Island cultures, the moon is seen as a guiding spirit, watching over travellers on the ocean. Tales of ancestral voyagers often mention the moon as a protector or companion. In other cultures, the moon's glow was used to explain how wayfarers avoided getting lost. In this way, the moon wasn't just a source of light, it was a symbol of guidance and a reminder of paths long travelled. There's also a practical comfort in having the moon overhead on a long journey. It offers a sense of stability in an otherwise featureless expanse. When you're surrounded by endless water, no land in sight, the moon becomes a familiar face. Its rise and fall offer a rhythm, a marker of passing time, and a subtle reminder that you're not entirely adrift. Today, of course, most people don't need the moon to find their way. Satellites beam our position down to pocket-sized devices with astonishing precision. Tidal tables are calculated with digital accuracy. Boats have radar, sonar, and automated alerts. But something about lunar navigation still resonates. It speaks to a quieter, more intuitive way of moving through the world, one that relies not on machines, but on attention, memory, and respect for the rhythms of nature. For thousands of years, humans watched the moon not just for beauty or inspiration, but for practical guidance. Its glow lit our paths, its pull shaped our coasts, its cycles helped us move with confidence across vast and unpredictable terrain. In a very real sense, the moon was our first travel companion. Long before road trips or airline tickets, it shone softly on the shoulders of voyagers, reminding them they were on course, and never entirely alone on the open sea. The moon has always been more than just a glowing rock in the sky. Long before we understood it as a cratered satellite shaped by gravity and ancient impacts, humans looked up and saw something much more personal. They saw stories, faces, animals, spirits, gods. The moon became a mirror for imagination, reflecting the hopes, fears, and questions of every culture that gazed into its pale, watchful light. Across continents and generations, people filled the moon's soft glow with meaning. It became a place of mystery, a celestial character that changed shape, vanished and returned, and followed its own quiet path through the heavens. Where science now sees orbital mechanics and reflected sunlight, early storytellers saw love, betrayal, trickery, and divine power. The moon was not just in the sky, it was of the sky, alive and filled with intent. In ancient Mesopotamia, the moon was a god named Sin, or Nana. He was one of the most important deities in the Sumerian and Akkadian pantheons, often depicted as a wise old man with a long beard, riding a crescent-shaped boat across the night. Sin controlled time, wisdom, and the calendar, a direct nod to the moon's role in measuring the passage of months. Temples were built in his honour in cities like Ur, and priests carefully tracked the lunar cycle to guide rituals and seasonal decisions. For the Sumerians, the moon wasn't just beautiful, it was an authority, a scheduler of sacred things. In nearby Egypt, the moon had a more complex identity. The god Thoth, often shown with the head of an ibis, was associated with the moon, as well as writing, magic, and wisdom. Thoth was said to have measured time, recorded the deeds of the gods, and even helped restore the sun when it was swallowed during eclipses. In Egyptian mythology, time itself flowed with the moon's rhythm, and Thoth kept it balanced, an elegant way to link the lunar phases to the cycles of life, death, and rebirth. Moving eastward, we find another lunar god in Hindu mythology, Chandra. Chandra is depicted as a shining, chariot-driving deity who rides across the sky drawn by 10 white horses. He is gentle, soft-spoken, and deeply connected to emotions, fertility, and healing. In Vedic astrology, Chandra governs the mind and moods, a poetic link to the moon's subtle influence on human emotion and behaviour. The phases of Chandra are seen as symbolic of life's emotional tides, waxing and waning just as we do in joy and sorrow. Meanwhile, in Chinese folklore, the moon is home to Chang'e, a beautiful immortal woman who lives in solitude after drinking an elixir of eternal life. Her story varies depending on the version, but most involve love, loss, and transformation. Some say she fled to the moon to escape punishment. Others claim she was protecting the potion from falling into the wrong hands. Either way, she ended up alone in the sky, forever gazing down at the earth. The Chinese Mid-Autumn Festival celebrates her tale, with mooncakes, lanterns, and family gatherings under the full moon. It's a time for reflection, togetherness, and longing, qualities often associated with moonlight itself. In Japan, the moon is also deeply woven into mythology and art. The Moon Viewing Festival, or Tsukimi, invites people to appreciate the full moon, often with poetry and offerings of rice dumplings. Japanese folklore tells of a rabbit who lives on the moon, endlessly pounding rice into mochi. If you look closely at the moon's surface, you might even spot the shape of the mythical rabbit among the craters and shadows. While Western cultures tend to see a man in the moon, East Asian stories favour the rabbit, each interpretation shaped by the stories people bring to the sky. In Norse mythology, the moon is personified as Mani, a male deity who drives the moon across the heavens in a chariot, pursued by a hungry wolf. His sister Sul does the same with the sun. The idea that the moon must constantly flee or risk being devoured added a drama to the sky, and explained the occasional lunar eclipse. In this cosmic chase, the moon's journey wasn't just movement, it was survival. In many Native American traditions, the moon takes on a more maternal or guiding role. Among the Cree people, the moon is a grandmother spirit, wise and watchful. Among the Inuit, stories tell of a brother and sister, sun and moon, who became separated after a dramatic conflict and now chase each other across the sky. These myths often serve to explain not only the moon's phases and path, but also the changing seasons, animal behaviour, and cycles of light and dark in the far northern latitudes. Then there are the tricksters. In some African and Pacific Island myths, the moon is a playful, sometimes unreliable figure. In one story from the San people of southern Africa, the moon promises immortality to a hare, but is misunderstood, and thus humans are cursed to die. The hare, in turn, is punished by being struck in the face, leaving marks that some say can still be seen on the moon's surface. It's a tale of miscommunication, mortality, and cosmic consequence, all wrapped in the soft light of the night sky. In the Americas, the moon was often seen as a counterpart to the sun, sometimes its partner, sometimes its rival. The Maya, who had an incredibly detailed lunar calendar, associated the moon with a goddess who watched over fertility and water. In many traditions across Central and South America, lunar eclipses were seen as dangerous omens, times when the moon was being attacked or stolen. People would bang pots, shout, or play drums to scare off the celestial predator and bring the moon back to life. The idea of the moon being stolen, eaten, or covered has popped up in cultures all over the world. Before the science of eclipses was widely understood, these events were unsettling. The moon, which was always there, always reliable, suddenly vanished or turned red. It was as if the sky itself had paused to take a breath. In response, people told stories of dragons swallowing the moon, of spirits hiding it, of divine battles playing out far above. And in telling these stories, people weren't just explaining the sky, they were expressing wonder. Fear, curiosity, hope, and love all made their way into lunar myths. The moon became a blank canvas for emotion. It watched over travellers and lovers, witnessed rituals, and served as a silent companion to those who walked alone. For the lonely, it offered company. For the joyful, it added sparkle. For the grieving, it gave a steady presence, unchanged even when everything else seemed to shift. Today, we understand the moon in a very different way. We've walked on it, measured its craters, mapped its mineral content. We know how it formed, how it moves, and why it shines. And yet, the myths haven't entirely faded. We still refer to it with affection, still mark important events by its phases. We still make wishes on full moons, feel a thrill when we see a halo around it, and tell children stories about rabbits or glowing faces in the sky. Science hasn't erased the moon's mystery, it has simply added another layer. Knowing how a lunar eclipse works doesn't make it less beautiful. Understanding that moonlight is reflected, sunlight doesn't make it feel less magical. The ancient stories may not be literal truths, but they capture something deeper, the human instinct to connect with what we see, to build meaning from light and shadow. The moon has always been part of our story, not just as a physical presence, but as a participant in our dreams, our fears, and our search for meaning. It rises, it falls, it changes shape, and we follow it with poems, prayers, and possibilities. Whether it's a chariot pulled by horses, a lonely goddess, a clever trickster, or a watchful grandmother, the moon is always more than it seems. It's not just above us. In some small, story-shaped way, it's within us too. Imagine sitting under a calm night sky, the moon glowing brightly above you. It's full, round and reassuring, like a lantern gently suspended in space. And then, slowly, something begins to happen. A shadow creeps across the moon's surface, dimming that silver light, turning it darker and darker until it vanishes entirely or glows a deep, unsettling red. Now imagine you have no idea why this is happening. For ancient people across the world, a lunar eclipse wasn't just an astronomical event. It was a cosmic drama, a celestial warning, or a moment of supernatural power. The moon, so dependable in its nightly appearances, was suddenly engulfed by darkness. No longer passive, it appeared to be under attack, swallowed or stolen, and naturally humans responded the way humans often do when faced with confusion. They made stories. In ancient Mesopotamia, eclipses were taken very seriously. Kings and priests interpreted them as omens, often warnings of upheaval or danger, especially for the ruling class. When a lunar eclipse was predicted or observed, the king might even temporarily step down, and a substitute would be placed on the throne to absorb the bad luck. Once the danger had passed, the unlucky placeholder was removed, sometimes in less than pleasant ways, and the rightful king would resume his duties, freshly cleansed of cosmic risk. In parts of India, people believed that eclipses were caused by a demon named Rahu. The story goes that Rahu disguised himself to steal a sip of the elixir of immortality, but was caught by the gods. Vishnu, acting swiftly, chopped off Rahu's head before the elixir reached his body. But because the head had already taken a sip, it lived on, and so Rahu's severed head occasionally takes revenge by swallowing the sun or the moon. Of course, with no body to hold on to them, the celestial objects quickly slip out of his mouth and return to the sky. A dramatic explanation for what is, from our modern perspective, a very predictable event. In Chinese folklore, a great dragon was believed to devour the moon during an eclipse. To chase the dragon away, people would bang pots and drums, shoot arrows into the sky, and shout loudly, all in the hopes of saving their glowing companion. It must have been quite a scene. An entire village making noise in the middle of the night, desperate to drive away a monster they couldn't see but were certain was there. In the Americas, many indigenous groups also had their own interpretations. Some saw eclipses as battles between the moon and other celestial forces. Among the Inca, it was believed that a jaguar was attacking and devouring the moon. In response, people would shout, make loud noises and rattle their spears to frighten the predator away. This wasn't just myth, it was action. Eclipses brought communities together in shared wonder, fear and ritual. Even in the absence of monsters or divine drama, eclipses have always had a way of capturing attention. There's something inherently unsettling about watching a bright, familiar object in the sky suddenly fade. It breaks the routine of the heavens. It reminds us that even things that seem constant are in truth part of larger, shifting systems. And perhaps most importantly, it taps into something ancient, the feeling that the sky is watching us back and that it too has moods. Now let's step back and see what's really happening during a lunar eclipse, using a bit of science, but in the gentlest way possible. A lunar eclipse occurs when the Earth moves directly between the Sun and the Moon, casting a shadow that falls across the Moon's surface. This can only happen during a full moon, when the Moon is on the opposite side of Earth from the Sun. Most of the time, however, the Moon passes slightly above or below Earth's shadow. That's because the Moon's orbit is tilted about 5 degrees relative to Earth's orbit around the Sun, but now and then, typically a few times a year, the alignment is just right. And when it is, Earth's shadow begins to sweep across the Moon. There are actually a few different kinds of lunar eclipses. A penumbral eclipse is the most subtle, barely noticeable to most observers. During this type, the Moon only passes through the outer part of Earth's shadow, known as the penumbra. It might look a little dimmer, a bit dusky, but the change is soft and easily missed if you're not paying attention. A partial lunar eclipse is more dramatic. Here, part of the moon slips into the darker central shadow, called the umbra. You can watch the Earth's shadow slide across the moon like a slow-moving curtain, covering part of its surface in darkness. And then there's the showstopper, the total lunar eclipse. In this event, the entire moon enters Earth's umbra. You might expect the moon to disappear completely, but it doesn't. Instead, it turns a deep, coppery red. This eerie glow is the result of sunlight bending through Earth's atmosphere and scattering. The blue and green wavelengths get filtered out, while the redder light continues on and gently wraps around the Earth, casting a blood-red hue on the lunar surface. It's a cosmic sunset projected across the moon. This phenomenon is sometimes called a blood moon, though the name has gained dramatic flair in recent years. Despite sounding ominous, it's just the result of atmospheric filtering, the same reason sunsets and sunrises are often so vividly red. If Earth had no atmosphere, the moon would go completely dark during a total eclipse. Instead, our planet gives it a quiet, rusty glow, a final gift before releasing it back into full brightness. While we now understand the mechanics, the emotional effect of a lunar eclipse hasn't faded. Watching the moon vanish, even briefly, remains a humbling experience. It reminds us that the sky isn't static. It moves, shifts, and dances to patterns far older than we are. These eclipses are gentle rehearsals of cosmic alignment, quiet moments when Earth casts its silhouette on its oldest companion. And unlike solar eclipses, which require protective glasses and specific locations, lunar eclipses are visible to anyone on the night side of the planet with a clear sky. No travel necessary. You can sit on your porch, lie in the grass, or lean out a window and watch the whole drama unfold, usually over several hours. The moon rises bright, then begins to dim, slipping into shadow. At full eclipse, it hangs there, red and quiet, before slowly returning to its normal silvery self. Of course, if you're trying to keep the moon's schedule and it doesn't show up as expected, that can be a little alarming. Imagine being an ancient stargazer, waiting for the full moon to rise, only to see it covered by an inky shadow. You might reasonably assume that something had gone terribly wrong. The moon's occasional disappearing act must have felt deeply personal, like losing a friend who had never let you down before. Today we no longer fear the loss. We know the moon will be back, shining as always, but the awe remains. A lunar eclipse is a reminder that the cosmos is not just a backdrop. It's active, it moves, and it plays with light and shadow in ways that still feel like magic, even when we understand the rules. So the next time you catch the moon slowly vanishing into darkness, or glowing red in the middle of the night, take a moment to think of all those who watched it before you. The kings who stepped aside, the villagers who shouted at dragons, the children who wondered if the moon would ever return. And then look up, smile and enjoy the show, because every once in a while the moon puts on its disappearing act, just to keep things interesting. For most of human history, agriculture wasn't something you did with spreadsheets and tractors. It was something you did with your hands in the soil, your eyes on the sky, and your hopes planted alongside your seeds. And when it came to the sky, one heavenly body in particular held a special place in the farmer's heart, the moon. Long before we understood photosynthesis or nitrogen cycles, we understood patterns. People watched the moon wax and wane, rise and set, and change its place in the sky with steady regularity. And they noticed something else too. Crops seemed to thrive when planted at certain times of the lunar cycle. Over generations, these observations gave rise to what we now call lunar agriculture, farming by the moon. Let's start with what that actually means. Lunar agriculture is the idea that the phase of the moon at the time you plant, tend or harvest your crops can influence how well those crops grow. It sounds a bit mystical, and to be fair, parts of it are rooted more in tradition than hard science. But that doesn't mean it's all moonshine. The most basic principle of lunar farming goes like this. The waxing moon, the period when it grows from new to full, is considered a good time for planting crops that grow above ground, like lettuce, beans, and corn. These are thought to benefit from the rising gravitational pull and increasing moonlight. On the flip side, the waning moon, when it shrinks from full back to new, is seen as better for planting root crops like carrots, potatoes, and beets, which grow downward into the earth. Why these specific timings? It all comes down to two main ideas. First, there's the influence of the moon's gravity on water. Just as the moon pulls the tides in the ocean, it also affects moisture in the soil. The theory goes that during the waxing moon, moisture is pulled upward toward the surface, encouraging germination and leaf growth. During the waning moon, the pull weakens and energy shifts toward the roots. The second idea is about moonlight. As the moon waxes and becomes brighter, it provides more light at night. Subtle, yes, but possibly enough to influence plant behaviour or the activity of insects and microorganisms in the soil. During the waning phase, with less light, growth is said to slow, encouraging sturdier root development. Now, to be clear, the scientific evidence supporting these claims is a bit hazy. Modern studies haven't found conclusive proof that the moon directly improves crop yields based on planting phase. However, that doesn't mean lunar farming is pure fiction. After all, traditional farming methods often contain a kernel of truth wrapped in generations of observation and practical wisdom. And when you're depending on the land for your survival, even a small edge, real or perceived, can feel worth following. In fact, many ancient civilizations used the moon not only for planting, but also for timing entire agricultural calendars. The Hebrew, Islamic, and Chinese calendars are all lunar or lunisolar, meaning they track months based on the phases of the moon. This wasn't just useful for holidays or festivals, it helped determine the start of planting seasons, harvest times, and when to prepare the land. The Babylonians were meticulous observers of the moon. They tracked lunar eclipses, rising times, and brightness. They believed the moon could signal good or bad times to sow, and their calendars were essential tools for organising agricultural labour. In ancient Egypt, the heliacal rising of Sirius and the lunar cycle helped predict the flooding of the Nile, a key moment for farmers, as the floodwaters deposited rich silt essential for crop growth. Even in Europe during the medieval period, lunar planting guides were included in almanacs and farmers' calendars. These texts would advise on everything from when to graft trees to the best days for cutting wood or harvesting grapes. The logic may have been more poetic than scientific, but it offered a sense of structure and ritual in an otherwise unpredictable relationship with nature. Let's not forget the moon's indirect but critical role in agriculture: tides. While most farming takes place far from the sea, tidal cycles matter a great deal for coastal and riverbank agriculture. In places like Bangladesh, the Ganges Delta's fertile plains are enriched and irrigated by tidal flows. Farmers in these regions have long timed their planting around tidal pulses, aided by lunar calendars passed down through generations. There's also aquaculture, farming fish, shellfish, and aquatic plants. Here, the moon's influence on water levels is very direct. Oyster farmers, for example, often rely on spring tides, which occur near the new and full moons, to manage harvesting and maintenance of oyster beds. The moon quite literally moves the water that sustains these aquatic crops. And what about the myths? Well, there are plenty. Some traditions hold that if you plant cucumbers during a full moon, they'll grow fat and juicy. Others suggest that cutting hay under a waning moon will make it dry faster and store better. There are beliefs that timber felled during a certain phase of the moon will resist rot, or that milking cows during the waxing moon will yield more cream. Whether or not these claims are testable, they reflect a deep cultural relationship with the moon, one where agriculture isn't just a science but a dance with nature. One of the more charming examples comes from biodynamic farming, a method developed in the early 20th century by Austrian philosopher Rudolf Steiner. Biodynamic farmers not only follow lunar cycles, but also consider the positions of planets and constellations when deciding when to plant, prune, or harvest. It's a bit like combining astrology with soil science. While mainstream science often treats it with a raised eyebrow, biodynamic practices have shown some success, not necessarily because of cosmic alignment, but perhaps because they emphasize attentiveness, observation, and care, traits that benefit any garden. Even today, many gardeners and farmers continue to swear by lunar planting, whether out of tradition, personal belief, or simply the comforting rhythm it brings to the seasons. Modern almanacs still publish moon phase calendars, and if you browse any gardening forum online, you'll find passionate defenders of the practice. From a psychological standpoint, working in sync with the moon can also offer a sense of connection to nature's larger cycles. It encourages patience, attentiveness, and ritual. Instead of planting whenever it's convenient, lunar farmers are invited to slow down and listen to the sky, the soil, and their own intuition. And while large-scale industrial agriculture may not coordinate its sowing schedules with the full moon, many small-scale farmers and homesteaders still look up before they dig down. For them, the moon isn't just scenery, it's a partner in the field. There's also something deeply poetic in imagining the moon as a quiet agricultural advisor. No push notifications, no weather app alerts, just a subtle glow in the sky, reminding us when to start, when to wait, when to reap, and when to rest. Food security too owes a surprising debt to lunar rhythms. In traditional societies, poor timing could mean the difference between abundance and hunger. Plant too early, and the frost might kill your seedlings. Plant too late, and the crops might not ripen before the cold returns. Using the moon's cycle as a natural clock helped communities coordinate planting across villages, ensuring better chances of survival and fewer failed harvests. And let's not forget that agriculture is more than just growing food, it's about storytelling. The moon, in its soft and steady way, has been part of that story from the beginning. It's there in nursery rhymes, harvest festivals, and the way we mark time with words like honeymoon, which originally referred to the full moon after a wedding, a sign of fruitfulness and new beginnings. In a world increasingly ruled by digital timers and artificial lighting, it's easy to forget that for most of our species' existence, we relied on the moon, not just to tell us when to sleep, but when to eat, when to plant, and when to hope. So even if the science behind lunar planting remains a bit cloudy, the influence is clear. The moon helped guide our ancestors through the uncertain art of agriculture. It shone on fields before electricity, pulled at tides before irrigation, and offered a quiet, dependable rhythm to lives shaped by the seasons. And in many gardens around the world it still does. Of all the quiet influences the moon has on our lives, perhaps none is more personal or more mysterious than its relationship with sleep. When the world is still and the sky is dark, the moon rises with a soft, watchful presence. It has no voice, no ticking hands or digital readouts. And yet, people across time and cultures have felt its subtle pull in their dreams, their moods, and their moments of rest. Throughout history, moonlight was one of the only sources of illumination after sunset, before electricity lit up our nights and blurred the lines between day and darkness. People lived more closely in tune with the lunar cycle. On moonless nights, darkness was deep and enveloping. On full moon nights, the landscape would glow in silver tones, shadows lengthened, trees shimmered, and rivers sparkled quietly as if stirred by invisible hands. For those living centuries ago, this change in light was not just atmospheric, it was behavioural. Nighttime activity often followed the phases of the moon. Full moons made travel easier, hunting more practical, and social gatherings more likely. People told stories, shared food, and sometimes even planned events according to the moon's brightness. In some cultures, certain festivals only occurred on full moon nights. Others used the dark moon, the time when the moon is entirely hidden, as a period of rest, reflection, or dreaming. And sleep? That's where things get especially interesting. For a long time, scientists were skeptical about whether the moon could actually influence our sleep. After all, we live in modern homes with curtains and climate control. Surely the old rhythms no longer apply. But recent studies suggest that the moon may still hold sway, even in our window-shaded, screen-lit world. One study published in the journal Current Biology found that around the time of the full moon, people tend to take longer to fall asleep, get less deep sleep, and wake up more frequently during the night. Interestingly, this effect occurred even when participants were in dark rooms without access to visible moonlight, suggesting the moon's influence might go beyond just brightness. Perhaps it's a biological rhythm embedded deep in our evolutionary history. Another study observed sleep patterns among rural communities without electricity, and found that people tended to go to bed later and sleep slightly less in the days leading up to a full moon. This makes intuitive sense. More light means more nighttime activity, even if that activity is just lying awake, staring at the ceiling, and wondering why you feel unusually alert under a sky full of glowing light. Of course, not all research agrees, and some studies find no consistent lunar effect. Sleep is a complicated, multifactorial process influenced by hormones, light, temperature, stress, diet, and lifestyle. But still, the moon lingers in the background, quietly suspect, like a ghost in the data. One theory is that the moon's brightness, especially before artificial lighting became widespread, suppressed melatonin, the hormone that helps regulate sleep. Melatonin production is strongly influenced by light exposure. When light hits the retina in the evening, melatonin release is delayed, pushing back sleep onset. A bright full moon might have been just enough to tip the balance, keeping early humans awake a bit longer than usual. Then again, maybe it's not just about biology. Maybe the moon captures attention. Maybe it's hard to sleep when the world feels a little different, glowing softly under a white circle that moves across the sky, like it has somewhere to be. Maybe it draws thoughts out of the body and into the open air, encouraging minds to wander just as eyes do. Moonlight has a way of awakening the imagination, of stretching the boundaries between dream and wakefulness. And dreams, that's another realm where the moon often appears. While there's no firm evidence that lunar phases alter the content of our dreams, the moon has long been linked to the subconscious. In literature, art, and myth, the moon is a symbol of intuition, emotion, and mystery, all things that dwell in the territory of dreams. In many languages, the word for lunatic has roots in lunar mythology. The Latin word lunaticus referred to someone believed to be affected by the moon. It was thought that the full moon could stir madness, heighten emotions, or bring vivid dreams. Today, the term is outdated and inaccurate, but it reflects how deeply the moon was entwined with mental states and nighttime rest. Modern culture still clings to these echoes. People speak of full moon energy, and emergency room staff and police officers will sometimes mention busier shifts on full moon nights, though the data on this is inconsistent. Whether by coincidence or collective belief, the moon continues to stir up feelings of alertness, emotional intensity, and sleeplessness. And yet, for all the tales of restlessness and agitation, there's another side to moonlight, the calming, almost meditative effect of bathing in its quiet glow. Imagine a peaceful countryside, the landscape painted in silver, trees sway gently, their leaves catching the light. An owl calls in the distance, and a breeze moves across your skin like a whispered lullaby. Under a full moon, even familiar paths feel enchanted. The world is still, but not asleep. There is presence in the quiet, and calm in the cold luminescence. In this kind of setting, the moon doesn't disrupt sleep. It deepens it. It invites reflection, soft thoughts, and gentle unwinding. People have long used moonlight walks as a way to process emotions or settle the mind. In poetry and music, the moon is a companion to solitude and introspection. It doesn't demand attention. It simply exists, steady, glowing, and non-judgmental. Even today, some people find it easier to fall asleep when they take a few minutes to step outside and look at the moon before bed. It's like pressing pause on a noisy day. There's no algorithm to scroll, no push notifications to respond to, just light, shadow, and silence. The moon asks nothing. It simply reminds you that time continues and that rest is part of the cycle. For some, it's not about looking at the moon at all. It's about syncing with its rhythm. They keep track of the lunar calendar, noticing how their own energy changes as the moon waxes and wanes. Full moons might bring clarity or emotional intensity. New moons might offer a clean slate, a quiet reset. Whether these feelings are symbolic or biological hardly matters. The act of observing the cycle creates mindfulness, and mindfulness makes space for rest. In that sense, the moon becomes more than a light in the sky. It becomes a metronome for the soul. It marks time not by deadlines and schedules, but by rhythms and reflections. And in doing so, it invites a different kind of rest, less about closing your eyes and more about softening your thoughts. So, while the science on lunar influence may be ongoing, the experience is undeniable. For millions of people throughout history, the moon has been part of the sleep story. It has watched over dreamers, stirred imaginations, whispered through curtains, and pulled at tides both oceanic and emotional. Whether it keeps you awake a little longer or coaxes you gently into dreams, the moon is there, rising, falling, glowing, and dimming. It follows its path, unchanged by our busyness, untouched by our sleep routines. But somehow it touches us all the same. As you drift into your own quiet rest, perhaps there's comfort in knowing the moon is still out there, watching the world in silence. A soft presence in the sky, reminding us that rest is natural and sleep is sacred. Even if sometimes the moon decides to meddle just a little. Some muses carry lyres or paintbrushes, others drift silently across the night sky, glowing with borrowed light and timeless appeal. The moon has never written a poem or painted a canvas, yet it may be history's most famous influencer, quietly nudging the hands of artists, musicians, and storytellers for millennia. It starts, of course, with simplicity. The moon is always there. It waxes and wanes, rises and sets, but never truly vanishes. And unlike the sun, it doesn't blind us with its brilliance. You can look at the moon directly, study its face, trace its craters with your imagination. It's mysterious without being distant, romantic without trying too hard, the kind of muse that just shows up, doesn't ask for credit, and lets you do your thing. Poets have been particularly smitten. The moon appears in the earliest written texts, from ancient Sumerian hymns to Chinese Tang Dynasty verse. In classical Japanese poetry, it's a symbol of loneliness, elegance, and impermanence. Haiku often frame the moon not as an object, but as a mood, a silver silence hanging between thoughts. In English literature, the moon's poetic journey is practically a saga. William Shakespeare mentioned the moon dozens of times. Sometimes it was comic relief, like in A Midsummer Night's Dream, where the moon has a role in a hilariously overacted play within the play. Other times, it was wistful or tender, as in Romeo and Juliet, where Juliet warns Romeo not to swear his love by the inconstant moon. That's quite the rebuke, romantic but moody and unreliable. Like many muses, the moon has baggage. The Romantics took this fascination and ran with it. Percy Bysshe Shelley, Lord Byron and John Keats all invoke the moon as a symbol of melancholy, mystery and longing. In Keats's To the Moon, he describes the moon as wearily yet patiently shining upon the world, a glowing figure of sadness, wisdom, and quiet endurance. The moon, in these verses, was more than scenery. It was a character, a mirror of the soul. In visual art, the moon has shown up just as often and just as dramatically. In ancient times, it was stylized and symbolic, often associated with gods and goddesses. The Greek goddess Selene rode a chariot across the sky. her crescent moon perched on her head like a crown. In Egyptian art, the moon was linked to Thoth, the ibis-headed deity of writing and knowledge. Even then, the moon was already being cast in a supporting role to human imagination. Fast forward a few thousand years, and the moon appears again, this time in oils and watercolours. Vincent van Gogh famously painted The Starry Night, a swirling nocturne where the moon hangs just off-centre in a sky alive with motion. Though not scientifically accurate, it's emotionally perfect. The moon in that painting doesn't just light the landscape, it holds it together. It's a quiet anchor in a sea of celestial chaos. Caspar David Friedrich, the German Romantic painter, returned again and again to moonlit landscapes. In works like Two Men Contemplating the Moon becomes not a focus but a presence, a witness, a partner in thought. His figures don't look at the moon for answers, they simply include it in their silence. Of course, not all lunar art is contemplative. In the surrealist works of Salvador Dali, the moon becomes playful, odd, sometimes unsettling. And in modern photography, the moon is often a dramatic focal point, huge, luminous, rising over cities or mountains like a cosmic stage light. In music, too, the moon has inspired countless compositions, each pulling at a different emotional thread. Classical composers adored it. Ludwig van Beethoven's Moonlight Sonata is perhaps the most famous. Though it was not named by Beethoven himself, the piece's dreamy, melancholic first movement has long been associated with moonlight on water. It's gentle, haunting, and slow. Perfect for late-night listening, or for quietly staring out of a window with a cup of something warm. Claude Debussy's Clair de Lune, which literally means light of the moon, is another favourite. It floats rather than walks, a series of soft notes that seem to land like feathers. It's romantic without being grand, like a whisper across the keys. No wonder it has found its way into so many films and quiet moments. It's the musical equivalent of moonlight drifting through leaves. Jazz artists embrace the moon with equal enthusiasm. Blue Moon, How High the Moon, Moon Glow. The titles alone tell you what they were gazing at. These songs aren't about astronomy, they're about emotion. The moon becomes a metaphor for longing, distance, and the bittersweet ache of being human under a night sky that's too beautiful to ignore. And then there's the moon in pop culture. Not just music and art, but film, television, and even cartoons. The moon has played everything from romantic backdrop to ominous overseer. It has exploded in science fiction, been colonized in fantasy, and winked knowingly in animation. In Georges Méliès's 1902 silent film A Trip to the Moon has a face, and gets a spaceship in the eye. It's whimsical, absurd, and iconic. In more recent decades, the moon became a stage. Quite literally, when humans walked on it for the first time in 1969, the moon went from symbol to setting, from metaphor to memory. Poets imagined walking there for centuries, but now we had footprints. The mystery didn't vanish, but it shifted. The moon was no longer just an idea, it was a place. And even then it didn't lose its cultural weight. The footage of the Apollo landing was silent in the vacuum of space, but on Earth it echoed with meaning. The moon had been sung about, dreamed of, worshipped, and feared. And now it had been visited, and still somehow it remained just as distant. The fascination didn't fade. If anything, it deepened. Musicians continued to write lunar ballads. Painters still gave it a place in their nightscapes. Poets kept describing it as if no one ever had before. The moon is a shapeshifter, not in form but in meaning. It can be lonely or comforting, cold or romantic, wise or sorrowful, depending on who's watching and what they're feeling. In modern times, it's also become a quiet rebellion against the artificial. The moon reminds us that not everything is digital. Not every rhythm is man-made. It waxes and wanes without an update. It shows up without a battery. You don't need a subscription to watch it. All it asks is that you look up. And look up we do. Sometimes to sigh, sometimes to dream, sometimes just to remember that there's more to the world than what's in front of us. The moon is, in a way, the original piece of slow art. It takes its time, it repeats itself, it lets you see the same thing again and again, and yet it never feels quite the same. Perhaps that's why it endures. In a fast-moving world, the moon offers the luxury of slowness, of silence, of reflection. Whether it's peeking through a skyline, hovering over an ocean, or framed in a bedroom window, it asks nothing of us except to notice. And in doing so, it gives us something back, a moment of wonder, a quiet feeling, a line of poetry forming where thought used to be. The moon has no marketing team, no online presence, yet its influence on culture and art is vast and undiminished. It has lit the canvas, stirred the stanza, and filled the score. It is both stage and actor, metaphor and muse. And the best part, it still hasn't charged a single royalty. Long before telescopes, before satellites, before humans could even imagine walking on another world, there was the moon, hanging steadily in the night sky, changing shape with quiet precision. It was the first celestial body that truly belonged to us. The moon didn't streak across the heavens like a comet or disappear like the stars at sunrise. It lingered, it repeated. And in doing so, it invited questions, some of the very first questions in the long story of science. For ancient astronomers, the moon wasn't just beautiful, it was useful. It offered one of the few consistent markers in a sky that seemed full of riddles. It waxed and waned in a reliable rhythm, repeating its phases every 29.5 days. This gave early humans something precious, a calendar. By observing the moon, ancient civilizations could track time, not just in days or seasons, but in months. The very word month comes from moonth, a reflection of just how foundational it was to the way we first understood time. Across many ancient cultures, the moon became a scientific anchor. The Babylonians, for example, were among the earliest to keep detailed astronomical records of lunar movements. They were astonishingly precise for their time. With no telescopes, just careful eyes and centuries of scribes, they could predict lunar eclipses and track the moon's path against the stars. They saw that the moon didn't just move in a simple circle, it shifted slightly from month to month, revealing a more complex cosmic dance. Their records weren't just academic. They were used to plan religious festivals, agricultural activities, and royal ceremonies. In a world without Google Calendar, the moon was the next best thing. In ancient China, astronomers paid close attention to the moon's phases and eclipses as well. Detailed records from over 2,000 years ago describe lunar eclipses with surprising accuracy. These observations weren't just for curiosity's sake, they had political weight. A misinterpreted eclipse could be seen as a bad omen, signalling dissatisfaction from the heavens. In many ancient cultures, astronomy and astrology were tangled together like vines. Still, beneath the mythology, there was real observation, real data, science in its earliest and most poetic form. The Greeks, as they often did, took things further. They asked not only when the moon changed, but why. One of the earliest attempts to understand the moon's behaviour came from Anaxagoras, a philosopher-scientist in the 5th century BCE. He proposed that the moon didn't emit its own light but reflected the sun's rays. That may sound obvious now, but at the time, it was a radical idea. The prevailing belief was that celestial bodies had their own internal glow. Anaxagoras also suggested that eclipses occurred when the Earth passed between the sun and the moon, a startlingly correct insight for someone with nothing but logic and a clear sky. Another Greek thinker, Hipparchus, made remarkable strides in measuring the moon's distance. Using observations of lunar eclipses and basic trigonometry, he estimated the distance to the moon to be about 238,000 miles, astonishingly close to modern values. Without modern equipment, he reached his conclusion with nothing but sharp reasoning and a knack for geometry. It's like building a spaceship with rulers and shadows. Fast forward to the Islamic Golden Age, and we find scholars in Baghdad, Cairo, and Cordoba building upon the Greeks' legacy. Astronomers like Al-Battani refined lunar tables, improved calculations of the moon's orbit, and corrected earlier errors. Their works were later translated into Latin and formed a foundation for the European Renaissance. During this period, observation became more systematic, more rigorous. The moon was still poetic, but now it was also mathematical. Then came Galileo Galilei. In 1610, he turned a telescope to the moon and changed the way we saw it forever. Up until that point, many believed the moon was a smooth, perfect sphere, a kind of divine marble. Galileo's telescope, primitive by today's standards, revealed something entirely different. He saw mountains, craters, valleys. He saw shadows stretching across the lunar surface, revealing a rugged and scarred world. This wasn't a perfect celestial object, it was a landscape, a place. Galileo's sketches of the moon's surface were revolutionary, not just for what they showed, but for what they implied. The heavens were not perfect and unchanging, they were real, physical, and just as messy as Earth. The moon wasn't an abstract idea, it was a world next door. From there, the moon became a central player in scientific advancement. Johannes Kepler used lunar eclipses to refine his understanding of planetary motion. Isaac Newton looked at the moon and saw the fingerprints of gravity. In fact, Newton's theory of universal gravitation was inspired in part by wondering why the moon didn't just fall to Earth. His answer, that the moon was constantly falling, but moving sideways fast enough to keep missing, offered one of the most elegant explanations in physics. In the 18th and 19th centuries, astronomers continued to study the moon's motion in ever greater detail. They noted small wobbles in its orbit, what we now call libration, that allowed us to see slightly more than half its surface over time. They mapped its craters and gave them names. The far side remained hidden, a mystery waiting for machines to uncover it. And then, in the 20th century, we sent those machines. Before astronauts set foot on the moon, we sent probes. The Soviet Lunar program and the American Ranger and Surveyor missions sent back photos and data, measuring soil composition, temperature, and radiation levels. These missions weren't just about bragging rights. They laid the groundwork for human exploration, and more importantly, they showed that science could stretch from Earth all the way to another world. When Neil Armstrong stepped onto the lunar surface in 1969, it wasn't just a political achievement, it was a scientific pilgrimage. Apollo missions returned not just with stories and photos, but with rocks. Real, dusty, ancient moon rocks, and those samples told us stories the moon had been keeping for billions of years. We learned that the moon is about 4.5 billion years old, that its surface has been bombarded by meteors for most of its existence, that it has no atmosphere to speak of, no wind or water to erode its features. This means its craters are fossils, snapshots of the early solar system frozen in time. And here's the twist. Studying the moon didn't just tell us about the moon, it told us about Earth. By comparing lunar rocks with Earth's geology, we gained insights into the early formation of our planet. We learned about planetary cooling, core formation, and the violent events that shaped our world. The moon, once thought to orbit us in passive silence, turned out to be a kind of cosmic diary. Today, lunar science is entering a new chapter. Space agencies around the world are planning missions to the moon, not just visits, but long-term habitats. There's talk of mining for resources, setting up telescopes on the far side, and using the moon as a stepping stone for deeper space exploration. But the scientific spirit remains the same: to observe, to understand, and to learn. Modern instruments can now detect the tiniest gravitational influences, measure isotopic ratios in moon dust, and monitor thermal patterns in craters. We've discovered ice in permanently shadowed regions at the lunar poles, frozen water that could someday support human life beyond Earth. And the moon's stable environment, free from atmospheric interference, makes it an ideal platform for scientific instruments looking out into the universe. All of this began with a simple question: what is that up there? A question asked by shepherds, philosophers, scribes, and students. A question that turned skywatchers into scientists, dreamers into explorers. The moon didn't give us the answers easily. It made us work, wonder, build tools, refine methods, and trust in observation. It reminded us that science begins not in labs but in curiosity, not with facts but with questions, and often those questions are best asked under a silver sky, lit not by electricity, but by the quiet pull of a neighbour that has always watched over us. In that soft glow, the moon has been both mystery and microscope, a mirror reflecting our growing understanding of the world and of ourselves. If the universe is filled with stars, hundreds of billions of them in each of hundreds of billions of galaxies, then where is everybody? This question, famously posed by physicist Enrico Fermi, continues to puzzle scientists and philosophers alike. If life is easy to start and common to find, shouldn't we be seeing signs of it all over the cosmos? One idea that offers a surprisingly humble answer is the rare Earth hypothesis. It suggests that while microbial life might pop up in many corners of the universe, complex life, intelligent, sentient, squishy, curious beings like us, might be extraordinarily rare. Not because the universe is sterile or stingy, but because the conditions required are shockingly specific. As if life needs not just any seat at the cosmic table, but a reserved one with just the right lighting, temperature, menu, and music playing in the background. And high on the list of those necessary conditions, a large, stabilizing moon. At first glance, this might seem like an odd requirement. Stars are vital, of course. They provide energy. Planets with atmospheres, crucial. Liquid water, definitely. But a moon, that silvery companion that quietly waxes and wanes above our heads, how could it possibly be a gatekeeper for advanced life? Well, as it turns out, our moon isn't just any moon. It's massive in relation to its planet. In fact, it's unusually massive. The Earth and Moon are sometimes described as a double planet system because the Moon is so large compared to Earth. No other planet in our solar system has such a proportionally hefty satellite. Tiny Pluto and its moon Charon come close, but Pluto's not even in the same weight class. And our moon doesn't just exist, it does important work. It helps stabilise Earth's axial tilt. Without it, our planet would wobble like a poorly thrown frisbee. This tilt is what gives us seasons, and the moon helps keep that tilt from swinging wildly over time. A planet with chaotic axial shifts might experience extreme climate changes, swinging from ice age to tropical jungle in just a few millennia. That kind of climate rollercoaster isn't ideal for delicate ecosystems, or for the slow, steady process of evolution. Then there are tides. The moon's gravitational pull creates tides that ebb and flow in a rhythmic, dependable fashion. This tidal movement helps mix nutrients in coastal waters, stirs life in intertidal zones, and may have been essential for life's leap from chemistry to biology. Those ancient tidal pools were likely nurseries for complex molecules, little bathtubs of potential, stirred gently, predictably by the moon. But all of this moonlight magic rests on an incredibly lucky beginning. The current leading theory for the moon's formation is the giant impact hypothesis. Around 4.5 billion years ago, a Mars-sized object, possibly named Theia, crashed into the early Earth. The impact was catastrophic. Debris from the collision was flung into orbit and eventually coalesced into the moon. But it had to be just the right kind of impact. Too small and no moon would have formed. Too large, and Earth might have been completely destroyed. The angle, speed, and size had to fall into a Goldilocks zone of planetary violence, just enough to make a moon, not enough to obliterate its host. This level of precision might not be common in planetary systems. In fact, when we look at the moons of other planets in our own solar system, we don't see anything quite like Earth's setup. Mars has 2 lumpy captured asteroids. Jupiter has dozens of moons, but none of them exert the same kind of influence over their host. Saturn's moons are icy and distant. No other planet in our celestial neighbourhood has a satellite that shapes climate, stabilises tilt, and quietly keeps planetary rhythms ticking for billions of years. So if we assume Earth's moon is a rare result of a rare event, and that its presence has been crucial to life developing and thriving here, then it follows that planets without such moons might have had a tougher time. Perhaps their climates are too unstable, perhaps their oceans never developed helpful tides, perhaps their early biochemistry never got the rhythmic push it needed. It doesn't mean that life is impossible elsewhere, it just raises the bar for complexity. Microbes are sturdy, flexible, and incredibly adaptive. They can survive in boiling vents, frozen tundras, radioactive wastelands, and deep beneath the crust. But to evolve into something with a nervous system, with limbs or lungs or a fondness for staring at stars, life needs a long stretch of relative stability. No sudden snowball Earths, no firestorms every few thousand years, just the kind of gentle steadiness that lets trial and error biology do its patient work. The moon, then, might be part of what makes Earth's environment unusually friendly to that slow unfolding. It's the quiet partner in a cosmic duo. The moon doesn't shine its own light, doesn't spin its own heat, doesn't send pulses of energy across space, but it keeps the rhythm, like a metronome in the background, and without that beat, maybe the song of life doesn't quite play the same. Of course, the rare Earth hypothesis is just that, a hypothesis. It's not universally accepted, and many scientists argue for a more optimistic view. With so many planets, around so many stars, surely some of them have the right conditions. Maybe some even have moons like ours. Or maybe other factors, like large planets acting as asteroid shields or unusually active tectonics, can compensate for a missing moon. We're still learning what's out there. Exoplanet science is in its infancy. We've found thousands of planets orbiting distant stars, but we don't yet have the tools to detect most of their moons. Moons are small, faint, and hard to spot even with our best telescopes. But as instruments improve, we may start seeing more of them, perhaps even catching glimpses of planetary systems with lunar companions as intriguing as ours. And if we do find them, we'll have more data to test this idea. We'll be able to ask, how common is it for a planet to have a big, stabilizing moon? Does its presence correlate with habitability, with stable climates, with biosignatures, and maybe, just maybe, with intelligence? There's also something quietly poetic about this. For all our scientific progress, for all our algorithms and equations, the moon continues to hold a special place, not just in our skies, but in our search for meaning. It's not just a reflector of sunlight. It might be a reflector of probability, of cosmic odds. A reminder that even something as familiar as the moon may, in the grand scheme of things, be extraordinary. It's tempting to think of Earth as ordinary, just another rock circling an average star in an average galaxy. But what if we're not average at all? What if Earth is rare? Not because life is rare, but because complexity is fragile. And what if, in a universe of possibility, a quiet moon is the unlikely ally that helped life take root, grow lungs, walk upright, and wonder where it all came from? The rare Earth hypothesis doesn't say we're alone, but it suggests we might be uncommon. Not in a boastful way, but in a delicate one. Like a rare flower in a vast meadow, blooming not because the conditions are common, but because everything came together just right. A good planet, a lucky impact, a gentle moon. And when you look up at the sky tonight, maybe you'll see it not just as a luminous disk, but as a quiet guardian. A reminder that life, as we know it, might owe its existence to a moon that's just the right size in just the right place, doing just the right things, day after day, night after night, for billions of years. Of all the celestial bodies influencing Earth, the moon might be the most quietly powerful. While the sun basks in glory and takes credit for just about everything warm and bright, the moon is the one tugging at the edges, steadying, guiding, and gently nudging our planet into the rhythm that allows life to thrive. One of its more understated roles is in maintaining Earth's climate stability, a behind-the-scenes act with long-term consequences. To understand this, we need to take a step back and look at how Earth spins. Our planet is tilted just a little, about 23.5 degrees relative to its orbit around the Sun. This tilt is responsible for our seasons. It means that during different parts of the year, either the northern or southern hemisphere is tilted more directly toward the Sun, leading to the warmth of summer or the chill of winter. But this tilt isn't fixed. It wobbles. Imagine a spinning top. As it twirls, it doesn't stay perfectly upright. Its axis wobbles in a slow circle, a motion known as precession. Earth does the same thing, but in a much more drawn-out fashion. One complete wobble takes about 26,000 years. That's a blink in geological time, but a long stretch for any single species. Now here's where the Moon steps in. Without it, Earth's axial tilt could swing wildly over time. Computer simulations suggest that in the absence of our Moon, Earth's tilt could vary from almost 0 degrees to as much as 85 degrees. That would transform the planet's climate from stable and predictable to a roller coaster of extremes. Imagine a world where the poles sometimes point directly at the Sun, turning Arctic ice into steaming jungles and flipping deserts into snowfields every few million years. The Moon acts like a gravitational damper, slowing down and limiting these shifts. Its mass provides a stabilizing torque that keeps Earth's axial tilt within a relatively narrow band, between 22 and 25 degrees, for hundreds of millions of years. That range is tight enough to maintain a climate conducive to long-term biological evolution. It means plants and animals don't have to reinvent themselves every few millennia to cope with wild swings in temperature and sunlight. There's more. The Moon also slows Earth's rotation. When our planet first formed, it was spinning much faster. One full day may have lasted only 4 to 6 hours. Over time, the Moon's gravitational pull has exerted a subtle drag. This process, known as tidal braking, has gradually lengthened Earth's days to their current 24-hour rhythm. The same effect is still happening, though at a glacial pace. Every century our days grow about 2 milliseconds longer. This gradual deceleration has had profound effects. A slower spin means more even heating from the Sun throughout the day and night. Rapidly spinning planets tend to have more intense winds and more chaotic atmospheric patterns. A slower rotation contributes to a calmer climate, especially when combined with the Moon's stabilizing influence on the tilt. But perhaps the most fascinating lunar connection to climate comes from long-term cycles. Those subtle changes in Earth's orbit and orientation that, taken together, are known as the Milankovitch cycles. Named after Serbian mathematician Milutin Milankovitch, these cycles include changes in Earth's eccentricity, how elliptical its orbit is, axial tilt, and precession. Together, these cycles influence how much sunlight different parts of Earth receive at different times of the year. And over tens or hundreds of thousands of years, they can tip the planet into or out of ice ages. When all three cycles line up in just the right way, summers in the northern hemisphere become cooler, which can allow snow and ice to build up year after year. This increased reflectivity, or albedo, cools the planet further and can kick-start a glacial period. When the cycles shift in the other direction, melting begins and interglacial warmth returns. The Moon plays a critical role in keeping these cycles predictable. By stabilizing Earth's tilt, it keeps the variation in solar energy within a range that Earth's climate systems can handle. Without the Moon, precession would be chaotic. The tilt could lurch, and the Milankovitch cycles might be less orderly, or even dysfunctional. That means ice ages might not follow a pattern. They might be more extreme, or they might never happen at all. Both outcomes would have profound consequences for the development of life. Glaciations, while dramatic, are important to the planet's long-term balance. They cycle nutrients, reshape ecosystems, and even influence atmospheric composition. For humans, they've sculpted the world we inhabit, carving valleys, creating lakes, and pressing the reset button on landscapes every so often. A stable, predictable cycle of ice and thaw may have been one of the hidden factors that allowed our ancestors to adapt, migrate, and thrive. Consider this. The most recent glacial period ended about 12,000 years ago. Since then, Earth has enjoyed a relatively mild and stable climate. Just the kind of gentle environment needed for the rise of agriculture, cities, and everything we call civilization. That entire stretch of calm weather may have been made possible, in part, by the Moon's influence on orbital stability. Even today, our understanding of the Moon's role in climate continues to evolve. Studies suggest that subtle changes in the Moon's orbit, as well as long-term variations in tidal strength, could affect ocean circulation patterns and even monsoons. The Moon might not be pulling the levers on a daily basis, but its fingerprints are all over the long-term balance. It's a quiet partnership. The Moon doesn't shine, heat, or roar. It pulls, just a little, just enough to keep Earth from wobbling out of step, enough to let climates come and go in rhythm rather than chaos, enough to let the delicate threads of evolution weave their tapestry without having to start over every few million years. In a universe filled with volatile planets, worlds that tumble, scorch, freeze, or flicker unpredictably, Earth stands out for its calm. And that calm isn't accidental. It's curated, maintained by a Moon that formed in fire and stayed to whisper in gravity's voice. The Moon doesn't demand credit. It's never hosted an atmosphere or erupted with lava like Io. It doesn't have rings or storms or gazers. It just drifts. And yet, without its steadying hand, Earth might be a very different place. A planet of sudden freezes, erratic heat waves, wild axial flips, and evolutionary dead ends. Instead, we live on a world where climates change slowly, where oceans follow regular tides, where seasons return on cue. A world that has stayed within the slim band of habitability for billions of years. Not too hot, not too cold. A world that lets forests grow, rivers flow, and creatures climb the long staircase from microbe to mind. All of that thanks in part to the Moon, a distant silent stabilizer, a guardian of rhythm in a universe that doesn't always value stability. And tonight, when you see it rising, pale, round, and familiar, it might help to remember that it's not just a beautiful companion, it's a planetary anchor, a timekeeper, and perhaps, in the slow language of gravity, a reason you're here at all. Life, as far as we know, began not in forests or meadows or sunny mountaintops, but in water. Long before creatures crawled or flew or built spaceships, they floated. The oceans were our first cradle, a salty, swirling soup of molecules bumping into each other, sometimes joining forces in ways that would change the world forever. But even in this liquid nursery, something else was at work, something that stirred the waters with gentle rhythm, mixing the chemicals, concentrating them, drying them just enough, and then wetting them again. That something, oddly enough, was the Moon. The tides are among the Moon's most visible gifts to Earth. They don't just tug at the edges of the sea, they breathe with it. Every high tide and low tide is a pulse in a planet-sized system, and those pulses reach into every bay, lagoon, and shallow shelf. For a long time, biologists have suspected that tidal zones, those places alternately submerged and exposed, might have been crucial in some of life's earliest and boldest steps. Imagine a rocky shoreline 4 billion years ago. Waves lap in, bringing with them dissolved minerals and organic compounds. The tide rises, filling shallow pools, then falls again, leaving behind puddles under the heat of the young sun. In those puddles, water slowly evaporates, concentrating whatever molecules were left behind. Heat and dryness cause some bonds to form. Then the tide returns and cools everything down, diluting the mix and allowing new reactions to take place. This cycle, wet, dry, mix, repeat, is one of the most promising mechanisms proposed for the origin of complex biomolecules like RNA and proteins. And what drove that gentle cycle? long before rivers carved valleys or wind-shaped deserts. The moon. Its gravitational pull stirred the seas in predictable ways, making sure those puddles didn't just sit still, but instead experienced the rhythmic chemistry of life's prelude. Of course, the story doesn't stop at the molecular level. Once primitive life did get going, the tidal zones remained important. They were transitional spaces, not quite land, not quite sea. Life here had to be adaptable. It had to handle changes in temperature, salinity, moisture, and sunlight. The organisms that thrived in tidal areas were often those with the flexibility to endure change. They became specialists in transition, which might explain why many evolutionary experiments happened right at the water's edge. One of the biggest of those evolutionary experiments was the leap from water to land. This wasn't a single event, but a slow, messy process that played out over millions of years. Some ancient fish began developing stronger fins, not to swim faster, but to prop themselves up in shallow oxygen-poor pools. Others evolved rudimentary lungs to gulp air when water ran low. Eventually, some of these creatures found that staying out of the water, at least part of the time, offered new advantages. Fewer predators, untapped food sources, open space. The intertidal zones may have been training grounds for these early pioneers. The moon, by continuing to orchestrate the dance of the tides, kept offering opportunities for organisms to adapt to dry conditions. And those who succeeded could venture a little farther each generation, until walking on land was not just possible, but normal. It's fascinating to consider how many major evolutionary innovations may have involved the rhythms the moon helped establish. Vision, for instance, may have been shaped in part by lunar cycles. Creatures that emerged at night needed to adapt to varying levels of moonlight. Too bright, and predators saw them. Too dark, and they couldn't forage. This arms race between detection and evasion may have helped shape nocturnal vision systems, retinas fine-tuned not just to darkness but to lunar nuance. Then there's reproduction. Many marine species synchronize their breeding cycles with the moon. Corals, for example, often spawn en masse during full moons, releasing eggs and sperm into the water in a spectacular glowing cloud. The timing ensures that gametes meet, and that the young drift into a sea teeming with the same hopeful beginnings. This lunar coordination isn't just convenient, it may be essential. Without it, reproductive success could drop drastically. Even some land animals, like turtles, rely on the moon's light and cycles to guide their behaviour. Female sea turtles come ashore to lay eggs on beaches during certain phases of the moon. Hatchlings, in turn, use the brightness of the moon to orient themselves toward the ocean. These rituals, evolved over millions of years, show just how deeply embedded lunar patterns are in the biological clockwork of Earth. There's another intriguing thought. Could the moon's influence extend all the way to cognition? Speculative, yes, but not implausible. The consistency of lunar cycles may have offered early humans a kind of natural clock, a template for prediction. Recognizing patterns like the phases of the moon may have encouraged the development of memory, anticipation, and abstract thinking. A full moon every 29 days meant something. It meant hunting would be easier. It meant tides would shift. It meant stories could be timed, passed down, remembered. This sort of pattern recognition is the foundation of intelligence. If our ancestors learned to associate certain events with certain lunar phases, they were not just surviving, they were beginning to think symbolically. And thinking symbolically is what eventually leads to language, culture, and science. Of course, not every evolutionary leap can be traced back to the moon. Natural selection is a tangled, multi-factored process. There were other influences: solar radiation, volcanic activity, asteroid impacts, competition, genetic drift. But it's worth recognizing that the moon, by setting a steady pace and establishing tidal rhythms, may have nudged life in specific directions, not by commanding, but by suggesting. In that sense, the moon isn't a sculptor, it's a metronome. It didn't carve life's shape, but it gave the beat that life could dance to. It didn't decide who would evolve lungs or legs or binocular vision, but it created the conditions that made those adaptations useful. It offered the rhythms, and evolution wrote the melodies. And maybe that's why the moon still stirs something deep in our collective imagination. It's more than just a light in the sky. It's a kind of ancestral memory, a pale reminder of all the gentle ancient pushes that brought us here, of the tides that mixed the first molecules, of the pools that dried and refilled, of the creatures that learned to wriggle, then crawl, then walk, then look up and wonder. We often think of evolution as a grand heroic tale, and it is, but it's also a story of timing, of chance meeting rhythm. And the moon, quiet and slow and reliable, may have been one of evolution's most consistent partners, not with a bang or a blaze, just a pull, a whisper, a repeatable pattern that life could count on. And all of it, incredibly, still happening tonight, out in the shallows, where the sea breathes in time with the sky. The moon may appear peaceful in the night sky, serene, glowing and timeless, but if you were to get a closer look, you'd quickly see it's anything but untouched. Its surface is pockmarked with craters, vast and small, silent echoes of a violent past. While we on Earth enjoy rolling hills, forests and oceans, the moon bears the scars of billions of years of cosmic impacts, and that's part of what makes it fascinating. The moon may be more than just a companion in orbit, it might be our very first bodyguard. Now, before we crown it Earth's personal shield, it's worth noting that this idea is still debated among scientists. The moon isn't enormous by cosmic standards, it's not parked in front of Earth like a giant umbrella, and space, frankly, is enormous. The chance of a specific rock in space hitting the moon instead of Earth is pretty slim, but still, the idea isn't without merit, and exploring it is a delightful mixture of astronomy, probability and poetic speculation. Let's start with the facts. The moon does get hit, a lot. Unlike Earth, which has an atmosphere that burns up many smaller meteoroids before they reach the surface, the moon offers no such protection. Everything that slams into it leaves a mark. That's why its face is so heavily cratered. Those circular scars from a distance give the moon its textured beauty. Up close, they tell the story of billions of collisions, some as recent as a few hundred years ago, others dating back over 4 billion years. One particularly large and ancient scar is the South Pole Aitken Basin, one of the biggest impact craters in the solar system. Over 2,000 kilometers across and about 8 kilometers deep, it's a silent monument to just how intense space can be. Impacts like that were not rare in the early solar system. Earth got pummeled just as badly, but here, plate tectonics, erosion, and vegetation have erased most of the evidence. The moon has kept the receipts, and that leads us to an interesting question. If the moon is getting hit so often, how many of those rocks might have otherwise struck Earth? The answer isn't entirely clear, but the basic idea is this. The moon orbits close enough to Earth, about 384,000 kilometers away, to sometimes intercept objects that might have continued on to us. It's not a guaranteed shield, but more like a travelling partner who sometimes walks ahead and takes a few bumps on our behalf. Statistically speaking, it's estimated that the moon reduces Earth's exposure to direct hits by only a small percentage. But that small percentage might be all it takes now and then to prevent a catastrophic event. And in the ancient days of the solar system, when the planets were still settling into their orbits and debris flew like cosmic shrapnel, even a modest reduction in impacts could have made a big difference, especially during a period known as the Late Heavy Bombardment, about 4 billion years ago. During this time, both the Moon and Earth were hit frequently by massive asteroids and comets. The difference is, Earth had developing oceans and early life. The Moon had basalt plains and silence. If even one fewer impact on Earth allowed life to hold on during those chaotic days, then perhaps we owe the Moon more than just tides and poetry. Another argument for the Moon's role as a kind of cosmic buffer relates to its gravitational influence. Though small compared to Earth's gravity, the Moon still exerts a pull, and it can nudge the trajectory of incoming objects just slightly. Sometimes that might mean pulling a rock away from Earth's path. Other times it might mean redirecting something into the planet. It's not always heroic, but even chaotic influence is still influence. Some researchers have proposed that the Earth-Moon system acts as a sort of gravitational partnership, altering the orbital paths of potential impactors in subtle ways. Again, the magnitude of this effect is small, but in space, small nudges can lead to large detours over long distances. A rock deflected today might miss us entirely in 1,000 years, or it might take the scenic route and circle back, hopefully after we've built better telescopes. Interestingly, the Moon may also help us understand Earth's own history of impacts, because it's essentially been keeping a backup record. By studying the ages and distribution of lunar craters, scientists can infer when and how often major impact events happened. Since the Moon doesn't erase its craters the way Earth does, it offers a clearer geological timeline. This has helped researchers piece together not just lunar history, but Earth's as well. One example is the realization that asteroid impacts have likely occurred in clusters, not randomly spaced events. These bursts might have been caused by disruptions in the asteroid belt or distant gravitational shifts that sent waves of debris into the inner solar system. If such patterns can be detected in lunar craters, it could give us a heads up about possible future periods of increased risk. And while we're talking about protection, it's worth mentioning that the Moon isn't Earth's only defense. Jupiter, our solar system's largest planet, is often credited as the true planetary bodyguard. Its massive gravity well can capture or redirect many comets and asteroids before they even reach the inner solar system. In that sense, the Moon may not be the only bouncer at the door, but perhaps it's the one closest to home, watching over the Earth from just across the sky. Whether or not the Moon has saved Earth from any specific disaster may never be proven definitively. But what's clear is that it offers a unique vantage point into the dynamics of our solar system. Its scarred face reminds us that cosmic collisions are not just possible, they're inevitable. Earth has been struck many times. Some of those events, like the one that wiped out the dinosaurs 66 million years ago, reshaped the course of life entirely. And here's a curious thought. That same event, the one that spelled doom for giant reptiles, made room for mammals to rise. Eventually, that evolutionary door opened wide enough for humans to walk through. So even in destruction, the universe works in cycles. Impact leads to extinction. Extinction creates opportunity. And maybe, just maybe, the Moon has helped steer that chaotic dance in less catastrophic directions. There's also something comforting about having a cosmic companion that bears the scars we can't see on our own world. Every crater on the Moon is a frozen moment in deep time, a reminder of how old the solar system really is, and how long Earth has been a target in a shooting gallery of space rocks. The fact that we're here at all is a statistical miracle. And the Moon, it's still up there, circling quietly, pulling the tides, lighting up the night, and occasionally, just maybe, getting in the way of something that was headed straight for us. Not a flawless shield, not a guardian angel, but a battered friend who's been through every storm and stuck around anyway. And that, in the cold logic of astrophysics, is pretty heartwarming. Long before rockets ever pierced the sky, the Moon was the destination of dreams. For ancient civilizations, it was a god or a goddess, a glowing timekeeper, a story written in silver ink across the night. It was always there, untouchable, serene, sometimes full, sometimes gone, but never forgotten. For thousands of years, humans stared up and wondered. And then, in the 20th century, someone dared to ask, what if we didn't just admire it? What if we went there? That question gave rise to one of the most astonishing chapters in human history. A chapter written not in myth or metaphor, but in steel, sweat, mathematics, and moon dust. The story of the Moon in space exploration is about more than just reaching a destination. It's about what it meant for us, as a species, to lift off from the only world we've ever known and touch another. The Apollo program was born in the heat of a geopolitical rivalry. The United States and the Soviet Union, locked in the Cold War, turned their eyes skyward in a contest of national pride. At first, the Soviet Union surged ahead, launching Sputnik, sending the first human, Yuri Gagarin, into space. The United States, jolted into action, responded with a bold promise. In 1961, President John F. Kennedy declared that before the decade was out, America would land a man on the moon and return him safely to Earth. It was audacious, and it worked. 8 years later, on July 20th, 1969, Neil Armstrong and Buzz Aldrin stepped onto the surface of the moon, while Michael Collins orbited above in the command module. Over 500 million people on Earth listened as Armstrong said those now iconic words, "That's one small step for a man, one giant leap for mankind." In that moment, humanity became a multi-world species, even if only briefly. What made Apollo so extraordinary wasn't just the engineering, though that alone was staggering. It was the fact that thousands of people, from scientists to janitors to seamstresses, who hand-stitched the astronauts' suits, worked together for a single goal. This wasn't just a technological achievement, it was a triumph of imagination, of cooperation, of sheer willpower. Between 1969 and 1972, 6 Apollo missions landed on the moon. 12 astronauts walked its dusty plains. They deployed experiments, collected rocks, drove lunar rovers, and left behind retroreflectors, mirrors that still bounce laser beams back to Earth, helping us measure the moon's distance with astonishing precision. These missions gave us more than souvenirs, they gave us knowledge. The moon turned out to be a geologic time capsule. Unlike Earth, its surface doesn't shift with plate tectonics or erode with wind and water. That means the rocks the Apollo astronauts brought back are nearly 4.5 billion years old, some of the oldest ever studied. These samples helped confirm theories about the moon's formation, including the idea that it was born from a colossal impact with a Mars-sized body early in Earth's history. In a poetic twist, by going to the moon, we learned more about Earth itself. Apollo also changed how we saw our home. From the moon's surface, Earth looked fragile, a glowing blue marble suspended in darkness. For astronauts who stood there, that view was both humbling and transformative. Many spoke of the overview effect, a sudden visceral awareness of Earth's unity and vulnerability. National borders vanished. Political squabbles seemed petty. The planet was small, delicate, and worth protecting. The moon, silent and ancient, had gifted us a new perspective. After Apollo 17 in 1972, the moon fell quiet again. For decades, no humans returned. But the science didn't stop. Robotic missions picked up where the astronauts left off. Orbiters mapped the lunar surface in exquisite detail. Landers studied its composition. New tools and satellites allowed scientists to detect water ice in the shadowed craters near the lunar poles, regions never touched by sunlight. That discovery, announced in the 2000s, reignited interest in the moon not just as a scientific curiosity, but as a potential outpost for future explorers. Water means life, or at least the possibility of sustaining it. If ice can be extracted and turned into drinking water, breathable oxygen, or even rocket fuel, the moon could become a refueling station for missions deeper into space. Mars, asteroids, and beyond suddenly become more reachable. Not in our lifetimes, Braves, but someday. International efforts have continued to grow. China, India, Japan, and the European Space Agency have all sent missions to the moon. In 2019, China landed a rover on the far side of the moon, the first ever to touch that hemisphere. It revealed terrain untouched by earlier missions and tested communication through lunar satellites. India's Chandrayaan missions contributed valuable data about lunar geology and water presence. The moon is once again becoming a crowded and cooperative frontier. In recent years, NASA has announced the Artemis program, named after Apollo's twin sister in Greek mythology. Its goal is to return humans to the Moon, including the first woman and the first person of colour, by the mid-2020s. This time, the plan isn't to plant a flag and go home, it's to stay, to build sustainable infrastructure, test technologies, and prepare for missions that reach even farther. And why return to the Moon when we've already been there? Because it's still the best proving ground for everything we need to do next. It's close, only a few days' journey. It has no atmosphere, which makes it an ideal place to test habitats, life support systems, and radiation shielding. It forces us to think creatively, to solve problems in harsh conditions, and it continues to hold secrets about planetary formation, solar history, and possibly even the early building blocks of life. There's something deeply human about our relationship with the Moon. We dream about it, we sing about it, and when we finally reached it, we left behind a plaque that reads, "We came in peace for all mankind." That phrase, etched into metal and planted in lunar dust, speaks not just to the politics of the moment, but to a hope that our better nature might guide our steps beyond Earth. The Moon will likely be our classroom for generations to come. Children who watch Artemis launch might one day walk those same grey plains. Engineers not yet born will design habitats nestled in lunar craters. Poets will write about the silence there, and maybe, just maybe, a new kind of civilization will rise, not to escape Earth, but to expand our understanding of what's possible. And through it all, the Moon will continue to orbit quietly, unchanged in its rhythm, but forever changed in our minds. What was once a distant beacon of mystery became a destination. What was once a symbol of the unreachable became a footprint in dust. We've always looked up at the Moon and wondered. Now we can look up and remember, and perhaps most powerfully we can look forward. Because the Moon, more than just a place, is a beginning. If, one quiet evening, the Moon simply began to drift away, slipping silently out of Earth's gravitational embrace, most people wouldn't notice at first. The sky would look emptier. The tides might behave strangely. A few stargazers might scratch their heads. But as days passed and then years, the consequences would become more profound and unsettling. Losing the Moon wouldn't be a single event. It would be a slow unravelling of systems we didn't even realise were stitched together by that quiet companion in the sky. First, let's imagine the mechanism. For the Moon to drift away, something dramatic would need to change in the balance of forces between Earth and its satellite. Currently, the Moon is actually moving away from Earth at a snail's pace, about 3.5 centimetres per year, thanks to tidal interactions. It's like an extremely slow breakup. But for this scenario, let's accelerate things a bit. Say, for argument's sake, that the Moon suddenly begins drifting away much faster, or is somehow ejected from Earth's orbit altogether. What happens? At first, the most immediate and noticeable change would be the tides. Right now, the Moon's gravitational pull is the primary driver of tides on Earth. The Sun plays a role too, but it's the Moon that stirs the seas with daily regularity. Without it, Earth's tides would be much weaker, perhaps by 2/3. That means smaller tidal ranges, less mixing of ocean waters, and a dramatic shift in coastal ecosystems. Tidal zones, those beautiful, bustling in-between spaces, rely on regular flooding and draining. They support unique life forms, facilitate nutrient exchange, and act as breeding grounds for many species. Without strong tides, many of those habitats would shrink or collapse altogether. Creatures that depend on tidal rhythms might struggle to survive. Fisheries could be affected, shorelines might become stagnant, and the pulse of the ocean, its breath in a sense, would slow. Beyond the tides, we'd start to see changes in Earth's tilt. One of the Moon's most important but underappreciated roles is stabilising our axial tilt. Earth is tilted at about 23.5 degrees, and this tilt gives us our seasons. The Moon helps keep that tilt steady, like a cosmic counterweight. Without it, Earth's tilt could begin to wobble chaotically over time. Imagine a planet where the seasons don't follow predictable patterns. Instead, over thousands, or even hundreds of years, Earth's tilt might swing wildly. At times, the poles could tilt closer to the sun, resulting in sweltering polar summers and frozen equators. Then, the tilt might shift the other way, plunging the poles into darkness for decades. This kind of climatic chaos would play havoc with agriculture, migration patterns and ecosystems. Entire biomes might collapse or shift latitudes. Human civilization, built on stable growing seasons and predictable weather, could face immense pressure. Our circadian rhythms too might change. While artificial lighting has dimmed the moon's influence on modern sleep patterns, it still plays a role in natural light cycles. For most of human history, moonlight governed nighttime activity. Without it, nights would become darker, especially in rural or undeveloped areas. For wildlife that relies on the moon for navigation, hunting or reproduction, the change could be profound. Coral spawning, turtle nesting, and countless other behaviours tied to lunar phases might become erratic or vanish altogether. And then there's the psychological impact. The moon isn't just a physical object, it's a cultural one. It's part of our collective imagination. Its absence would be noticed emotionally, perhaps even spiritually. Songs would feel incomplete. Literature would lose a muse. Entire mythologies would face revision. For many cultures, the moon represents balance, renewal, mystery. Its loss would leave a hole not only in the sky, but in the human psyche. Astronomically, Earth would be a lonelier planet. Among the many worlds in our solar system, Earth is unique in having such a large moon relative to its size. That companionship has shaped our history in more ways than we know. If the moon were to disappear, night skies would grow darker and stars more brilliant. That might sound beautiful, but the familiar glow we've always known would be gone. And then there's the long-term orbital consequences. The Earth-Moon system is a dance of mutual gravitational pull. The moon affects Earth's rotation, gradually slowing it down. Without the moon, that process would halt. Our days would stop lengthening, and Earth's rotation might even shift in unexpected ways due to solar tides. Over immense spans of time, the planet's spin could speed up slightly, or wobble irregularly. Let's pause here for a moment and think about the evolutionary consequences if Earth had never had a moon to begin with. Without tides to stir the primordial soup, would life have even begun in the same way? Would it have had the same opportunities to evolve complexity? The moon may have nurtured life's early stages, offering cyclical drying and wetting, conditions ideal for complex chemistry. Its absence might mean a planet that remained microbial, or one where evolution took a vastly different path. But our scenario isn't a moonless Earth from the start. It's a moon that departs mid-story. That's an altogether different tragedy. The ecosystems, seasons, behaviours and technologies that evolved in sync with the moon would begin to falter. Civilizations that once used it to mark time, navigate the seas, plant crops and tell stories would find themselves adrift. Not just literally, but metaphorically. The cultural loss might be just as severe as the environmental one. From ancient calendars to modern poetry, the moon has always been more than just a rock in the sky. It's a symbol of cycles, of reflection, of change and permanence. Removing it would be like erasing a word from every language on Earth, a very important word. Of course, some aspects of life would go on. Humans are adaptable. We have artificial lighting, clocks, satellites and supercomputers. But our adaptations have always built upon natural rhythms, not replaced them entirely. Losing the moon would mean losing the blueprint behind some of those rhythms. It would mean confronting a slow shift in everything from climate to psychology, with each new generation adapting to a world that feels just a little more unfamiliar than the one before. In a way, the moon acts like an old friend, quiet, steady, always present, rarely the centre of attention, but sorely missed when gone. We don't often stop to thank it for holding our planet's tilt in place, or choreographing the tides, or lighting up midnight forests. We take its constancy for granted, and yet, without it, we might unravel. One tide pool, one calendar, one myth at a time. So if you find yourself outside on a clear night, take a moment, look up at the moon, notice its glow, its craters, its soft influence on the world below. Because even though it's been slowly drifting away for billions of years, it's still with us, for now. A silent partner, holding things steady, pulling gently at the sea and the soul alike. Here is the full script for Chapter 21, The Moon's Future with Earth, written as requested. The moon is drifting away from us, slowly, gently, silently. It's not the kind of breakup you notice in a hurry. There's no dramatic flinging of cosmic luggage, no slammed planetary doors, just a steady parting of ways at a pace so calm it could almost be poetic, about 3.5 centimeters farther each year. That's roughly the same speed your fingernails grow. Not exactly a galactic sprint, but over long enough time scales it adds up. This gentle separation has been going on for billions of years. When the moon first formed, it was much closer, perhaps only 20,000 to 30,000 kilometers from Earth's surface. Today, it sits at an average distance of about 384,000 kilometers. In those early days, it would have looked massive in the sky, perhaps 20 times larger than it does now, and would have caused tides so dramatic they might have towered tens of meters high. Entire coastlines would have pulsed with water, life, and energy. Earth was a wilder place then, and the moon was its restless twin. The reason the moon is drifting away lies in a subtle exchange of energy. As the moon's gravity pulls on Earth's oceans, it creates bulges in the water. These bulges don't align perfectly with the moon's position in the sky. Because Earth rotates faster than the moon orbits, the bulges are pulled slightly ahead. That offset exerts a gravitational tug on the moon, pulling it forward in its orbit. And in space, when you pull something forward, you give it energy. The moon gains momentum and spirals outward. At the same time, Earth pays the price. It's losing a tiny bit of rotational energy, which means our days are gradually getting longer. In the far distant past, a day on Earth may have lasted only 6 hours. Now it's a little over 24. In a few 100 million years, the day will stretch out even more, adding minutes, then hours, all while the moon floats slowly farther away. Eventually, very eventually, Earth and the moon will become tidally locked to each other. Right now, the moon is already tidally locked to us. That's why we only ever see one face of it. But someday, Earth will return the favour. It will rotate once for every orbit the moon makes, always showing the same face to the moon. When that happens, our day will be about 47 current Earth days long, and the moon will appear much smaller in the sky, far more distant and faint. This process will take billions of years, and there's a bit of a cosmic race going on. You see, Earth may not be around to complete the dance. The sun, too, has its own timeline. It's burning through its hydrogen fuel steadily and predictably, growing brighter and hotter with age. In about 1 billion years, the sun's increased luminosity will make Earth's surface far less hospitable. Oceans may evaporate. The atmosphere could become thick with water vapour, turning Earth into a sweltering greenhouse world. By that point, life as we know it might be gone or have moved on. The moon will still be drifting, but the planet it once stabilised will be changing rapidly. Fast forward another few billion years, and the sun reaches the end of its main sequence. It will swell into a red giant engulfing Mercury and Venus, and possibly Earth as well. There's still debate over whether Earth will be fully consumed or simply scorched and stripped of its atmosphere. Either way, the planet will be unrecognisable. The moon, now much farther away, might escape being swallowed, or it might be drawn into the chaos, its fate sealed in a final fiery embrace. Assuming the moon survives the sun's transformation, it may drift through space as a lonely relic, orbiting the burned-out remains of its parent planet, or perhaps becoming a rogue object, captured by another celestial body in the vastness of space. It's a solemn picture, but also a deeply beautiful one. the story of a companion that stayed by Earth's side until the very end. In the meantime, before these grand endings unfold, the moon's slow drift has quieter effects. As it moves away, solar eclipses are gradually changing. Right now, the moon is just the right size and distance to perfectly cover the sun during a total solar eclipse. It's one of the most precise and breathtaking alignments in nature. But this won't last forever. Because the moon is receding, it appears smaller in our sky. In about 600 million years, total solar eclipses will become impossible. We'll only see annular eclipses, where the sun blazes around the edges of the smaller moon like a ring of fire. That means we're living in a unique window of time, one where the moon and sun appear the same size in the sky. A cosmic coincidence. We're not the first to witness this, and we won't be the last, at least for a while. But eventually it will pass, and the moon will take its grandeur with it. Despite the moon's retreat, its influence will linger. The marks it has left on Earth, both physical and cultural, will remain etched into the crust and the consciousness of any life that remembers. The craters on its surface will continue to record the history of the solar system. The quiet pulse it lent to life will echo in fossils, sediments, and memories. And who knows what intelligent beings, if any, might one day study the moon from afar. Perhaps long after humans are gone, another species, born from Earth or elsewhere, will look at the moon and piece together the story. They might study its orbit, its composition, and its scars. They might realize it once played a vital role in the history of a little blue planet. They might even visit, walking in the footprints we left behind, wondering who we were. The moon's future, like its past, is wrapped in quiet inevitability. It will not crash into Earth. It will not suddenly vanish. It will drift, slowly and faithfully, a little farther each year. A dance measured not in moments, but in epochs. It's humbling to think that such a small grey world could have had such a profound impact on Earth's history, and that its story is still unfolding 1 centimetre at a time. The moon doesn't blaze with energy like the sun, or swirl with storms like Jupiter. It doesn't glitter with rings or burn with heat, but it endures. It reflects. It stabilizes times and tugs. It inspires. And long after our days are numbered, after the last tide has slowed and the final eclipse has passed, the moon may still be turning, circling, waiting for whatever comes next. Here is the full script for Chapter 22, A World Lit by the Moon, written as requested. In a world that never stops spinning, where news cycles outpace heartbeats and digital clocks tick louder than the wind, the moon remains. Quiet, pale, unwavering. It doesn't rush. It doesn't boast. It simply climbs the night sky, round or waning, waxing or thin as a whisper. It has lit the paths of poets and farmers, lovers and astronomers, wanderers and warriors alike, for generation after generation. There is something profoundly human about our relationship with the moon. Long before telescopes or tide charts, before cities rose and maps were drawn, there was the moon. Hanging overhead like a silent metronome, it marked time not with numbers or alarms, but with light and shadow. It watched us from its perch in the sky while we built fires, told stories, and peered upward with wonder. Its glow is not its own, and yet it feels so personal. The moon doesn't burn, it reflects. The light it casts is borrowed, softened, turned gentle by distance and time. It takes the blazing energy of the sun and transforms it into something calming, contemplative. In that way, the moon is a cosmic mediator, a reminder that not everything bright must be blinding, that even the fiercest forces can find a peaceful form, and that peace matters. It matters especially in the quiet hours of the night, when minds begin to wander and worries surface like driftwood on a still lake. The moon becomes a steady companion in those moments. Whether full and luminous or just a sliver of silver, it offers a kind of reassurance, an unspoken promise that some things endure. Across cultures and centuries, that promise has been honoured with stories. The moon has been painted as a goddess, a trickster, a wise old man, a celestial rabbit. It's been a clock, a guide, a lover, a warning. It has been the inspiration behind lullabies and scientific revolutions alike. From ancient Mesopotamian tablets to the frescoed domes of Renaissance cathedrals, from sacred calendars to grainy televised moonwalks, the moon has left fingerprints on our collective imagination. And while we've sent robots and astronauts to its surface, touched its dust and planted flags in its soil, we haven't lessened the mystery. If anything, standing on the moon only made us look back at Earth with deeper awe. From the moon, Earth is a fragile marble floating in blackness, a single, shimmering oasis. The perspective the moon gives us is humbling. It invites reflection, not just on the sky, but on our place beneath it. It is also simply beautiful. There is a rare kind of stillness to moonlight. Unlike sunlight, which energizes and awakens, moonlight invites a pause. It softens edges, mutes colours, slows the world. Shadows stretch longer, trees become silhouettes, rivers shimmer with silver threads. Even the most ordinary landscapes are transformed into something gentle and dreamlike. A field becomes a storybook, a city becomes a hush. For animals, that light has meaning too. Nocturnal creatures time their movements with the moon. Mating calls rise under full moons. Coral reefs synchronize their spawning with lunar phases. The moon's glow guides migrations, rituals, cycles of survival. It's not just romantic, it's ecological. The moon touches life in ways both subtle and profound. And for humans, it has been a tool, a calendar, a compass, a mirror. But perhaps most enduringly, it has been a symbol of rhythm, of return, of change that is consistent, of constancy that allows transformation. The moon waxes and wanes, but never disappears. It reminds us that light can fade without vanishing. That renewal is not only possible, it is inevitable. Even now, in a world so flooded with artificial light that it's easy to forget the stars exist, the moon still finds its way into our windows and poems. It still pulls at the tides and the soul. It still quiets conversations and lifts eyes upward. It still moves us, even if we don't always notice. And maybe that's the magic of it. The moon doesn't ask for attention. It doesn't demand worship or fear. It simply shows up, every night, in some form or another, carrying the weight of millennia on its cratered shoulders and the dreams of every civilization in its glow. It is easy to forget in the busy pace of modern life that our ancestors once planned entire seasons around the moon's phases, that they lit fires and held ceremonies by its cycles, that they feared eclipses and celebrated full moons, that entire belief systems were shaped by its presence in the sky. And yet, even without those rituals, the feeling lingers. It's in the way we still stop and stare at a full moon rising over a horizon. It's in the way we describe emotions as waxing and waning. It's in the way we use words like lunacy and moonstruck, language echoing our fascination. The moon isn't just an object in the sky. It's a mood, a metaphor, a mood light hung above the world. It has lit the faces of storytellers and astronauts, wolves and whisperers, those who've wandered forests and those who've studied the stars. It has inspired sonatas, haikus, oil paintings, and silver screen romances. It has been painted with longing, love, and a little mystery. And perhaps that's what we need most. Something that can't be rushed, monetized, or fully understood. Something that simply is. In the grand scheme of the cosmos, our moon is nothing special. Just one of many natural satellites orbiting many planets across many galaxies. But to us, it's everything. It shaped our tides and our myths, our clocks and our calendars, our science and our silence. And no matter how far we go, whether we build lunar bases or terraform Mars or drift through interstellar space, the moon will remain one of our first mirrors, the first skyward reflection of our need to know, to understand, to reach. It is our neighbour, our companion, our quiet reminder that the universe doesn't always shout. Sometimes it simply glows. So if you find yourself outside some night, perhaps a bit restless or reflective, and the sky's clear enough, look up. Let your gaze settle on that ancient orb. Let it remind you of stillness. Let it slow your thoughts, if only for a moment. The world may be restless, but the moon is not. The moon is patient. The moon is there. And in that glow, perhaps, there's a kind of peace. A world lit not by urgency, but by presence. A world lit by the moon. The moon has been with us from the very beginning. Quiet, faithful, and ever watchful. Long before cities rose or languages formed, before the wheel turned or fire warmed a cave, there was the moon rising over a sleeping earth. It cast its borrowed light on early oceans, glinting on waves pulled by its invisible hand. It illuminated the footsteps of our distant ancestors, their shadows long and wavering across ancient stones. Through storms and ice ages, empires and revolutions, it remained, circling above with a kind of cosmic patience that few other things possess. It doesn't sparkle or roar. It doesn't demand awe. And yet it has inspired more of it than perhaps anything else in the sky. Its phases guided the first calendars. Its presence stirred our first myths. Its pull helped sculpt our very biology. It shaped the rhythm of tides and sleep, of planting and prayer. Quietly, it kept time for Earth before we ever did. The moon doesn't need to shine. It reflects. It borrows sunlight and transforms it into something softer, more contemplative. A light that doesn't blaze. It glows. Gentle enough to soothe, bright enough to guide. The moon became a symbol of constancy in our restless world. A silent partner in our journey through time. We've watched it and written about it. We've sung to it, told stories under it, dreamed beneath it. And when our curiosity grew too large to contain, we reached out. We built machines to break gravity's grip and land softly on its surface. And when that first footprint pressed into lunar dust, humanity became a species that had stepped beyond its cradle. The moon was our first great leap outward, and it greeted us, as always, with silence. We often look to the moon for answers, but perhaps its greatest lesson is not in speaking, but in stillness, in reminding us that there is strength in presence, in quiet cycles, in simply returning, night after night. It has outlasted every empire, every boundary, every flag raised in haste or hope. It offers no judgment, just light. It's remarkable, really, that something so distant could feel so familiar, that no matter where you are on Earth, whether in a bustling city or a lonely plain, the moon is there, sharing its slow, celestial dance with you. It ties the human experience together across continents and centuries, a shepherd to tides and time. And as we consider our future on this planet or perhaps beyond it, the moon will always be part of that story. If humanity leaves Earth someday, bound for Mars or the moons of Jupiter, or the stars themselves, the moon will still be the first world we touched, the first great outpost of human wonder. It will always be the place where we prove to ourselves that the impossible could be real, that dreams, with enough patience and physics, can take form. But more than that, the moon reminds us of who we are. Curious, tenacious, poetic. We are creatures who look up, who search for patterns, who assign meaning to shadows and light. And whether we see it as a scientific marvel, a mythic mirror, or simply a beautiful face in the night sky, the moon reflects something essential back at us. The desire to understand, to feel connected, to belong to something greater than ourselves. So tonight, whether it's a crescent, a gibbous glow, or a radiant full circle, take a moment to notice it. Let its pale light touch your thoughts. Let it remind you of everything it's seen and everything it's still yet to witness. The moon asks nothing of us. It only offers presence. And if you've made it to the end of this video, whether you're wide awake or gently drifting off, I hope the moon feels a little more familiar to you now, a little more magical in the way only truth can be. And if it kept you awake, well, at least you learned something under its watchful eye. If you enjoyed this journey, I would be truly grateful if you gently tap the like button or subscribe to The Sleepy Scientist. It helps me keep making these calming explorations of our incredible universe. And as always, I'd love to know, where in the world are you listening from and what time is it there? Let me know in the comments. It's a quiet joy to imagine all the places were connected by the same gentle moon. And finally, please remember, this video is for educational and entertainment purposes only, and is not intended as medical advice of any kind. Wherever you are tonight, may your dreams be lunar lit, your thoughts serene, and your world just a little bit quieter. Good night.